Hey everyone, welcome to Edureka's YouTube channel. My name is Vardhan and I'm here to give you a quick overview of this blockchain full course. So blockchain's popularity soared really high in a very short time and now everybody wants to learn blockchain. So that's why we've come up with this video where we've categorized various concepts you need to know about blockchain into several modules. Let's look at those modules first. In the first module, you will understand what exactly is blockchain and why is there so much hype around this technology. In the second module, you will learn about blockchain applications. You will understand how blockchain applications thrive under the concept of decentralization. In the third module, you will understand what is a blockchain wallet, what are its different types, and how it works. In the fourth module, you will understand what is Ethereum. And by the end of the fifth module, you will exactly know what is the difference between Ethereum and Bitcoin. And then when we go to the sixth module, you will understand what is Ethereum development. You will understand the various tools and technologies in this ecosystem. And then in the seventh module, you will learn about smart contracts and how to deploy them in a local test environment. And then in the eighth module, you will finally learn how to develop your own distributed blockchain application, which is written on Solidity programming language. And then when we go to the ninth module, you will learn about Hyperledger. And in the 10th module, you will learn about hash graphs. And finally, in the 11th module, we will share a list of frequently asked blockchain interview questions so that you can find a job in this domain. While I strongly suggest you to complete this entire video, I also have another petty request to make. Please subscribe to Edureka's YouTube channel and hit the bell icon so that you'll get updated with all our videos. Happy learning!
Hello everyone, this is Neil from Edureka and welcome to this blockchain tutorial session. Now blockchain and Bitcoin are some of the most trending keywords as part of today's technology, and even those who are not familiar with cryptocurrency are quite interested in the same. And today's session will give you a complete idea with respect to both. Without wasting any time, let's move forward and look at today's agenda for the session. Now blockchain is being used highly for transaction management and it is replacing the current existing transaction management system. If a technology is replacing the existing systems, there must be certain problems, and that's exactly what we'll be discussing at the first. Once we've understood this, let's try to discuss how Bitcoins can help solve these issues as well as how the Bitcoin transaction takes place. Now if a transaction has to take place, there needs to be certain medium, and that's exactly what blockchain is. Moving on from there, we'll try to talk about the various blockchain concepts, the various blockchain features, as well as we'll see where blockchain is being used apart from the banking domain. Finally, towards the later half of this session, we'll be looking at a banking use case demo where what we'll be doing is we'll try to create an alternative banking system as well as we'll try to make it a bit better. Since you are reinventing something, let's try to make it better than anything that is there. So for that, first what we'll be doing is we'll be installing Go Ethereum and then we'll be registering an account to Go Ethereum blockchain. Go Ethereum basically is an online blockchain system which helps you manage your cryptocurrency. Once you've done this, we'll try to create a private autonomous blockchain on our system itself, and then we'll try to perform transactions internally. Now these are mock transactions, but it'll at least give you a complete idea of how a blockchain system works as a whole. So without wasting any time, let's move forward to the first topic of this session, that is the issues with the current banking system. Now the first challenge we'll be talking about is the transactional fees. Now let's take the simple example here. When Chandler wants to send $100 to Joey, due to a transactional fees of $2, Joey ends up getting only $98. Now, it may not seem a huge amount, but let's assume that every day there are 10,000 transactions that happen. And in that 10,000 transaction, even if it's a 2% commission, it's a huge amount that we're talking about. Now, if you look at what is given here, in the year 2015, three organizations, that is JP Morgan, Bank of America, and Wells Fargo, made close to $6 billion just from ATM and overdraft transaction fees. So this is a very huge amount, and most banking and financial organizations depend on these kinds of fees to have their source of income as well. Now wouldn't we all like not to have a transaction fees, because every transaction that we make, be it in an ATM, be it a net transfer, be it bank withdrawal, everything these days comes with a fixed transaction fees. Even though it would be a small amount, wouldn't we be happy if we could save that? Definitely, I do want to save that. So moving forward, let's talk about the next problem that is there with the existing banking system. Now this is a challenge that you would have seen if you're from a financial domain, but to those of you who have not heard of double spending before, let me put it very simply. Take the example here. Peter has $500 in his account. But what he's trying to do is that at the same time he's trying to send James $400 and Mary $500. Now if both transactions go through at the same time, then it becomes problem to identify which is valid, because the digital signature attached to which digital transactions can be to an extent falsified and copied as well. This makes double spending quite possible and is something that is of a challenge. Now this is one challenge that most banking or digital financial solutions had faced across when they were working with online payment transactions. Apart from this, there's also the challenge of financial crisis and financial depression. Now, all of us remember the depression that had happened in the year 2008. Now, to put it very bluntly, one of the key factors which led to this depression was because financial organizations and banks had actually lent out all their money as subprime mortgages to people who couldn't afford to pay them back. This in turn led to a huge fall with respect to real estate value and created a huge financial crisis for everyone who was associated with respect to that. A lot of people lost their jobs as well as money, but then again, this was something that people had done to try to get rich. So now comes the question that how can Bitcoin solve these issues? Now to understand this, let's take these four issues in itself. The first is the issue of centralized power. Now when I talk about a centralized power, every monetary system that's out there today is controlled by a central governing authority. It could be a federal body, it could be a unanimous personality, and so forth. Almost all currencies out there today are actually controlled to an extent by a central authority. However, with Bitcoin, this system got decentralized and distributed among everyone who was part of the Bitcoin system. And it keeps growing on. Let's say tomorrow you move into the Bitcoin system, then definitely you are also part of it and you hold a certain power to that as well. Now how that happens, that we'll be talking in our upcoming sessions as to how the value of Bitcoins keeps changing. But for now, let me just help you understand that anyone who becomes part of the Bitcoin and blockchain system becomes a powerful person, and the power that is held by one single authority gets distributed to everyone who's part of the network. Apart from this, most banking and financial organizations follow a private ledger. The only thing that you're aware of when you put your money into something is whether or not there's certain transaction that you have made as a person as such. You have no idea whether someone else has taken some money, whether the bank has in itself invested this money somewhere, and so forth. However, with blockchain system, the ledger in itself is public. Everyone who becomes part of this blockchain network gets a complete copy of the entire blockchain as soon as they sign up. So immediately when you sign up for the Bitcoin blockchain, you get a list of complete transactions that has happened from the start of Bitcoin transaction. Now that's a huge amount of transactions, but blockchain makes it very easy as well as completely secure to store all this transaction detail, and at the same time ensures that none of this gets manipulated. As to how this can be completely secure, we'll be talking in the upcoming slides, but I hope you get a simple understanding. Now, although it is a public ledger, you can have the complete details with respect to the transaction that happens as part of the network. You still don't know who exactly is doing this transaction. And this is the anonymity that blockchain gives you. Really neat, right? Now, the other challenge that most transaction and financial organization faces is the challenge of hacking. Every now and then we do hear that a financial organization has been hacked and certain data has been leaked, certain transaction details are released, certain amount has been stolen from their accounts, and so all this is something that we have heard every now and then. But blockchain system is completely immutable to hack. Any transaction that takes place cannot be modified ahead. And even if you try to modify it, the blockchain system is built so securely and so smartly that this false transaction detail gets rejected. Now, don't worry about how this happens. We'll be talking about that in the upcoming slides. Moving forward, coming to the final challenge, that is the double spending problem. As I had mentioned, most financial organizations that have a digital platform have faced the challenge of double spending. Through blockchain system, double spending is not possible. And this is basically because of how the blockchain system in itself was structured and created. Now, the double spending problem was something that was faced quite popularly at the time when the blockchain system was becoming popular. Keeping this in mind, they had structured the blockchain system in such a way that even in future, the challenge of double spending can be completely tackled without any problem. Until date, you do not have any transaction that was part of the double spending issue. Now, the first challenge that we had spoken about was the transaction fees. Now, today there are close to 650 different kinds of cryptocurrency, but Most of them don't even charge a minimal transaction fees. You can transfer your money from one account to the other account at no transaction charge. But let's say if you do wish to add a specific transaction charge, you can do that. There are certain cryptocurrencies that do follow a specific transaction fees, but this is comparably minute when you see the transaction fees that is associated to a bank transaction. So since all of you have understood till here, let's talk about the Bitcoin transaction system. But before we actually talk about the Bitcoin transaction system, what we need to understand is what exactly is blockchain. Blockchain basically is the core technology behind Bitcoin in itself. You can say it is the spine of Bitcoin system. To put it quite simply, blockchain is actually a public distributed database which holds the encrypted ledger. So why is it encrypted? To keep the details of the people involved in it completely anonymous. Apart from this, what exactly is a block, you might be wondering. A block is a collection of all the recent transactions that have happened and are verified. You group all these transaction details, create a hash code for this, and then you store it in a block. Once the transaction is verified, then what happens is this block becomes a permanent part of the blockchain and the chain keeps growing. So it is believed that every 10 minutes a new block gets created and the blockchain keeps growing accordingly. So how many transactions happen with respect to that time frame, all can be grouped as part of the block and then stored into the blockchain's block. But then again, you might be wondering, what exactly is Bitcoin in itself? So don't worry, that's exactly what we're talking about next. Now Bitcoin is the first decentralized digital currency that came into the market and was introduced in 2009 by a pseudonym called Satoshi Nakamoto. Now he brought in the concept of Bitcoin and blockchain together in an open paper, and this was something of a revolution. It was not until July 2009 the first blockchain came into implementation and became quite popular since then. Now you may be wondering, since it's a decentralized and a digital currency, can't we just keep creating bitcoins as per our needs? The answer is no. Bitcoins use various cryptographic as well as mathematical problems that ensure that the creation as well as management of bitcoins is restricted. Now, there are only 21 million bitcoins that can be created, and as on 2016, we've almost created 14 million of them. So what Bitcoin community has done is that they keep upgrading the algorithms as well as cryptographic technologies involved in Bitcoin on a regular basis. This ensures that even if there are more miners that come into the Bitcoin technology every day, that the Bitcoin system does not get exhausted. With the increase of complexity, it ensures that only by 2140 does the last Bitcoin get mined. Apart from this, the ledger system, which keeps a track of how much Bitcoin gets transacted, is in itself completely electronic and highly secure. Now, if you need to change any specific transactions, let's say you are trying to send someone Bitcoins that you don't have. Let's say I want to send 500 Bitcoins to every one of you who are part of this session. This becomes impossible, because the ledger in itself is completely electronic, as well as every transaction is verified and validated before it gets added to the block. Now going back to our previous topic, that was blockchain. Now in a block there are mainly three key concepts. The first is the previous block's hash code. Now every block has a specific hash code associated with it, which is used as an identifying factor for that block. Now this hash is something that gets created with a very complex hashing algorithm, where even a minute change with respect to the input can create a highly different hash output as whole. Now you cannot reverse engineer this hash code as well. The algorithm is created in such a way that no one can actually get the complete data by reverse engineering the hash code as well. Apart from this, you have the complete hash details of every transaction that has happened as part of that block. Now there could be multiple transactions that happen at one go, so every verified and validated transaction gets added to block, with thereby ensuring that this transaction cannot be manipulated. Apart from this, the third thing that needs to be part of a block is basically the value or proof of work for that block. This basically is a mathematical solution that you attach with a block to ensure that this is a valid block. Now we're not going to go in detail with respect to the mathematical proof, but we'll talk about that in the upcoming slides. Now you may be wondering, since it is a ledger and everyone has access to it, can I just not directly modify the ledger or the transaction? Definitely not. These ledgers are something that gets created by softwares which in itself have to solve a mathematical problem to get the valid output. So as I had mentioned, all the output gets hashed, and this hash value is what becomes a proof of work. So even if you try to falsify, or even if you try to fake a specific transaction or a detail with respect to the ledger, it is not going to get accepted. Apart from that, since the ledger in itself gets distributed throughout the network, everyone has a valid copy of the same. Let's say if you try to change even one specific transaction which is part of the block, it does not get accepted because majority of the people of the network have a copy of the block which is valid. So your modified block or transaction gets completely rejected and does not become part of the original blockchain as a whole, thereby ensuring that every transaction as well as every block is highly secure as well as valid and verified. So moving forward, let's try to understand how a Bitcoin transaction takes place. Now let's take a group of 8 people who are part of my blockchain network. Okay, you have James, you have Steven, you have Rahul, Kevin, Paul, Robert and Lisa. Now James wants to transfer 500 Bitcoins from his account to Kevin's account. Now just because James wants to transfer 500 Bitcoins to Kevin's, it may not seem possible. To give you a better example, let's say I want to give every one of you who are part of this session 5 crore rupees. Sadly, I don't have enough balance, so I can't do that. But that same thing needs to be validated by someone else. And that's exactly what the role is of Robert and Lisa, who are special professionals called miners. Their main job is to see whether James actually has enough sufficient balance. Now, there are a lot of protocols as well as security features that come into this, and we'll be talking about each one of them one by one. James here wants to transfer 500 Bitcoins to Kevin, and Lisa and Robert's job is to verify that they have sufficient balance. Now, before we go on, let's look at a sample ledger here. Here you have account number as well as the balance that is there after each transaction takes place. Now, this balance gets updated every time a transaction gets introduced, and the ledger in itself gets updated with respect to every transaction. So here, rather than having the details with respect to one single account, you store the details with respect to the transaction as part of the block. This again ensures that even though there are details with respect to the transaction available, you cannot directly attack or hack the end user and take away his money from his wallet. Although there are different kinds of cryptocurrency system in the market today, to give you a simple example, blockchain system actually keeps count of the unspent transaction output, whereas your systems like Go Ethereum follows an account-based system where an account balance is also stored. So based on different kinds of requirements by the user, you have different kinds of blockchain in itself. But we're going to be talking mainly about Bitcoin blockchain itself. So we'll be talking about the unspent transaction output. That is the amount of Bitcoins that are unspent. Now before we move forward, let's assume that the third entry present here is of James, who has to send 500 Bitcoins to Kevin. So I'll take this entry to be Kevin's. Okay, I hope all of you can see this. Now here what needs to be done is that 500 Bitcoins has to be taken from this account and has to get transferred to this account. Now if the transaction is successful, since James has sufficient balance, the transaction will definitely go forward and the account balance of Kevin gets updated with respect to everyone who holds the copy of the ledger. That is, this transaction is successful, gets broadcasted to everyone across the network who is part of the blockchain, and they themselves update their ledger accordingly. But then you might be wondering, whose job is it to verify that this transaction goes through and James has sufficient balance? That exactly is what the job role of miners Lisa and Robert is, as we have discussed earlier. Now what is going to happen is that Lisa and Robert are in turn going to check the complete transaction history of James. They're going to see if at any point James has received more than 500 Bitcoins or at least holds a corresponding previous balance of above 500 Bitcoins. So let's say there has been a scenario where Rahul had sent him 600 Bitcoins. So this in turn makes it quite easy, and you can immediately see that okay, he has received 600 Bitcoins. So I don't need to look any more further. I can definitely ensure that this transaction can go through, since James has not spent it also. But let's say James has received from Steven, let's say 200 Bitcoins, Rahul has sent him 100. So I need to keep checking all the previous transactions to verify that he has sufficient balance, including his credit as well as debit history, and then decide whether this transaction can go through. Now this is exactly what Lisa and Robert as miners do. Now once they have validated that James has sufficient balance in his account to transfer 500 Bitcoins to Kevin, then what happens is that this transaction gets added as part of the block. And once the block in itself gets validated, the money gets reduced from James's account and goes to Kevin's Bitcoin account. Now usually this whole process of a block validation gets completed in 10 minutes, but it is suggested that you wait about 30 minutes to confirm a transaction. Now again, since every transaction gets validated by a miner, they go back to all their previous history and keep checking. Now let's say James at the same time had tried to send 500 to Kevin and 500 to Rahul, having only 500 as part of his balance. Then what would happen is, since each transaction is individually being checked, the transactions would go through one by one. Now since James has sent Kevin 500 bitcoins, the transaction which is sent from James to Rahul won't go through because he recently just spent 500 bitcoins and he only had 500 bitcoins as part of his Bitcoin wallet. So therein it completely avoids the problem of double spending that we had discussed earlier. So are you guys clear with respect to how a Bitcoin transaction system takes place? Why would Lisa and Robert actually sit down and validate their transactions? What do they have to gain? The miners who validate the transaction as well as complete the next block of the blockchain get a 12.5 Bitcoin as an incentive for the creation of the new block. Now this is something that gets created out of thin air and gets added to their Bitcoin wallet associated to it. Now 12.5 Bitcoins is not a small amount. In today's value, it's somewhere about $33,000 to $34,000, which is a very huge amount. And you also need to understand that almost every 10 minutes a new block gets created and becomes a part of blockchain. So you can assume that every 10 minutes $33,000 gets credited into someone's account. But it's not as simple as you think. Mining requires a lot of investment, and as I had mentioned, it's not easy for one single person to mine the resource. So in today's world, what happens is a lot of miners come together and form something known as a pool. These people invest all the resource that they have to solve the pool together, and based on how much resource that they have invested in mining the pool, reward gets distributed accordingly. Now let's take a real-time scenario, $33,000, and let's say there are 11 people as part of that. Each one gets close to $3,000 in itself. $3,000 again is a huge amount for something that requires 10 minutes to mine. But again, let's not go into how much efficient it is to mine the resource and all that. We will talk about that in the upcoming sessions as well. But just to give you a simple idea, there's an incentive also added to Lisa and Robert. Now, again, there are a lot of sites that help you do this. But again, what I would request you is to check whether you're actually going to get any profit before you become a miner. Because again, the resource needed for mining a block is not less, and day by day it keeps increasing as well, because the complexity involved in solving a block keeps growing day by day. As we had mentioned earlier, there is a certain level of complexity that is involved in mining, and this keeps growing as time goes, because a lot more people are mining today when compared to 6 or 8 months back, and this is mainly because of their attraction for the incentives. But at the same time, since more miners are coming, we need to ensure that the Bitcoin system does not get depleted. As I had mentioned earlier, there's only 21 million Bitcoins that can be mined. So the system in itself makes it difficult for you to compute the resource. And as I had mentioned, just check how efficient it would be for you to become a miner. Now it's time we try to understand how blockchain achieves the Bitcoin solution or the Bitcoin parallel system. Now, what happens first is that there's a request for transaction initiated. Basically what happens is someone requests a transaction. Now it's quite easy for anyone to request for a transaction. All you need to do is that you need to have the details to whom you're sending. And with respect to details, you need to just have a unique number that they're going to be sharing. Now what exactly is this unique number? We'll be talking in the upcoming slides. But there are certain cryptocurrency wallets that even let you scan the QR code of the sender and initiate this transaction as well. So it's quite easy. All you need to do is enter one specific unique number that they provide you with. You have to enter your unique number, and then you need to specify the amount that you need to send to them. Once you do this, it gets transmitted across to everyone who's part of the Bitcoin network. Once they receive that and validation of this transaction is done, then the verification goes on, and then this transaction becomes part of the new block which is going to be added to the existing blockchain. Once the new block is created, it goes on to get added to the existing blockchain, and the transaction process gets completed. Herein it also avoids the need for a third party who in turn acts as a mediator between the sender and the receiver. Thereby this exactly avoids the need for a transaction fees as well, and is one of the key factors that has increased the popularity of blockchain and Bitcoin network as such. Great. So moving forward, if you talk about blockchain itself, blockchain basically is the spine of Bitcoin system. It is again a publicly distributed database where you're holding encrypted ledgers of everyone involved in the blockchain. Now once a transaction gets verified and validated, it becomes part of the new block, and the new block in turn gets added to the blockchain. Now the number of transactions at this point could be all the recent transactions or only those that have been completed as well. This depends on the total number of transactions that get verified and validated in the time that a new block gets created. So each block, once it's completed, gets added to the blockchain and the next block's work begins. Again, the next set of transactions get added on to this block, and in turn it gets added to the blockchain, and it ever keeps growing up. Now, as I had mentioned, once you join the blockchain, you can get the complete block list right from 2009 when the first blockchain was implemented. Moving forward, let's try to address the three key features that make blockchain so popular. The first is the blockchain cryptography. Now, you use a combination of public key and private key cryptography, apart from also using a highly secure hashing algorithm. Now, this hashing algorithm is so precise as well as complex that even a single space or a comma can make a huge difference with respect to that same. Apart from this, we use a P2p network, that is a peer-to-peer network, which ensures that there is a complete consistency with the blockchain. Let's say even if one person tries to make a slight change with respect to a transaction or a block which is part of the blockchain, then that changed block does not get added or reflected in the blockchain. Because most people in the network have the original blockchain, this changed block does not get accepted and gets rejected as well. Apart from that, the program in which blockchain is created has a lot of protocols as well as security feature in itself. Now, talking about the private key cryptography, here again you use a public key and a private key. What you do basically is that you share your public key. This is similar to the account number that we had discussed earlier. So what usually happens is that in case if you do want to send your money to someone, you basically request them for their public key, and then what you do is you share your public key, their public key, as well as the amount that needs to be sent as part of the transaction details. Now, based on what data you're sharing, you can select whether it has to be encrypted by the public key or the private key, and the other would be used for decrypting the data. It's completely an asymmetrical encryption process that takes place. Now, apart from this, we use a P2P network. How does the P2P network work? Now, suppose A, let's call A as Andy here, finds out that a transaction has come in which Bobby wants to transfer 5 bitcoins to Cindy. What happens is that A broadcasts this message to both B and C, who in turn verified it and transmitted accordingly to their peers as well. Now, once they have transmitted to their peers, they keep transmitting it across the network, and this transaction gets propagated throughout the network. Once this transaction gets propagated and a new block is about to be created, the transaction gets verified and validated and then gets added to the new block in itself, thereby keeping a complete consistency. Now, you may be wondering what happens when one person as part of the network tries to make a modification with respect to this transaction details. As I had mentioned earlier, it is not possible. Let's say this node is called D. Now, what he does is that he actually modifies the data, suggesting that the amount has to come to D rather than it has to go to C, and he propagates it to his nodes. Now, what happens is that once this gets propagated throughout, there's a majority and a minority difference here. Now, there's a certain limit that D can propagate his data to. But since the majority of the people have the correct details that it is B who wants to send the 5 bitcoins to C, not D, the transaction detail with respect to which is original gets accepted and the modified transaction detail gets rejected. Now, I hope this gives you an understanding of how secure the P2P network is, as well as what happens when you try to modify the transactional data. It's mostly based on a majority vote here. Apart from this, is also another preference that comes into the picture, but right now let's not talk about it and complicate things further. Now, moving on further, let's talk about how the distributed ledger system itself works in the P2P network. Now, let's say Andy is sending Bobby $5. Bobby is then giving Debbie $3, and Debbie thereby is giving Cindy $1. Now, this is a complete cycle that keeps happening, but we have only one central ledger which keeps tracks of it. What happens if this central ledger gets corrupted or some problems comes with respect to this data? Then the complete details with respect to the transaction is lost. Debbie can always tell that he's not taken $3 from Bobby, and same could be said by Bobby himself to Andy. Since the central record is not there anymore, there's no proof with respect to that same. And this is where exactly a distributed ledger comes. A distributed ledger ensures that everyone who's part of the cycle has a copy of the ledger, thereby ensuring that no fraud can happen or no changes with respect to that. Now, even if Andy loses his record of the transaction detail, he can take it from Bobby, Debbie, or Cindy. And if either of them try to make a change with respect to that, always the alternative copy can ensure that this is the actual transaction that had happened. So now moving forward, let's try to understand how a digital signature works with respect to it. Now, a digital signature is a very important part of the transaction detail because it ensures that the person who's sending the money is the real person, as well as the amount that is being transacted is the correct amount. So what happens is you mainly take the public key of the sender, the public key of the receiver, and as well as add the amount that has to get transmitted. Once you take this, it's fed to a hash algorithm and then it gets encrypted by a private key, which then is added as a digital signature to your document. Now, this is the same document that has the public key of the sender, public key of the receiver, as well as the amount. Once it gets transmitted across the network, you feed the data to a hash algorithm, which then again hashes the amount that has to be sent, the public key of the user, as well as the public key of receiver. You also decrypt the signature that is attached to this document using a public key that is being provided, and then you check if the hashes are same. If it is same, then it is understood that this is a valid transaction and this has not been modified as such while it is being propagated. So this in turn is another security feature that ensures that no transaction can be directly manipulated as well. Now, apart from this, another major key feature is the blockchain program. Now, the blockchain program is not something that can only be implemented in the banking domain. It's being right now implemented across multiple domains and has provided one of the new generation solutions, as well as overcome most of the challenges faced by a previous generation of applications. Apart from this, blockchain can be implemented using any language as per the user's requirement. But right now, Solidity is the most preferred language for writing blockchain programs. Talking about the blockchain transactions, in any blockchain, every transaction that gets verified and validated in the process of creation of a new block is logged along with the information of time, the participants, as well as the amount that gets transmitted across. Each node of the network, that is each user who's part of the blockchain, holds the complete blockchain in itself. So even once you join the blockchain, you get a complete copy of the blockchain from the start. Usually there's a 24-hour validation process that takes place, but after 24 hours, once you've set up your blockchain network, you can go on to perform various operations as part of it. Talking more about the transactions involved in a blockchain, each transaction is verified by a miner after he solves a complex mathematical puzzle. And once he solves this and verifies the transaction, he maintains and updates the ledger as well. Now, the mathematical principle which is involved as part of the validation process ensures that every node which is part of the blockchain are automatically and continuously in sync with respect to the current state of the ledger and every transaction in it. Basically, it ensures that everyone has the same set of transactions as well as same state of ledger as well. Apart from this, as I had mentioned, even if one person tries to corrupt or change the transaction part of it, the other nodes would not agree with it and thereby refuse to incorporate and neglect this transaction detail. Now, moving forward, let's talk about three types of blockchain. There are mainly three types of blockchain. You have public blockchain, private, and consortium blockchain. Now, public blockchain is similar to your Bitcoin or Go Ethereum blockchain, which anyone in the world can be part of. You can both read as well as write data into this blockchain if you're a miner, and also you can read data if you're part of the peer-to-peer network as well. So anyone who's part of the network can verify and add a new block of transactions that is part to this blockchain. Private blockchain, however, is something that is quite restricted. Usually only one central person has the complete right to both verify the transaction as well as add a new block to the blockchain. However, consortium blockchain is something that is between public as well as private. Here what happens is that instead of one person, it becomes a group of people. Let's say there is a group of 10 banks. Among them, 5 may be chosen who can both verify as well as add a new block as part of the blockchain. Now, with respect to the view that is available, a public blockchain is something that anyone can access to. As we have seen, the Bitcoin as well as Go Ethereum blockchain is something that anyone can download and work with. But at the same time, private and consortium blockchains are created and managed with respect to their specific purposes. you may not always be able to access a private or a consortium blockchain because they may be set to a specific user's requirement. However, there are certain private as well as consortium blockchains which are accessible to the public, but again this is something that the user has to do, that is the creator of the blockchain has to set accordingly. Now if you do wish to create a blockchain which is accessible to the public but lets you only add or modify it, then definitely you can do that as well. And we'll talk about how this can be done as part of the session as well. So let's just summarize what we have talked about blockchain. Blockchain basically uses various mathematical functions as well as algorithms to create a highly secure as well as a distributed ledger system which enables transactions to take place without a need for a third party or any need for transaction or commission requirement. You don't have to depend on a third party to take your transaction through, and this is one of the key reasons why the blockchain system is referred to as a no trust system. It's not that you don't trust someone, you don't have to put your trust on a third person to complete your transaction. It is something that gets completed without a problem. Now let's move forward and look at some of the blockchain use cases and understand where exactly is blockchain being used apart from the Bitcoin system. Now these are some of the most popular domains where blockchain at presently is being used. Now we've talked about the banking domain where blockchain is currently replacing the existing as well as overtaking the current existing system, as well as the payment and transactional system. The Bitcoin wallet system has grown so rapidly that it becomes quite easy for anyone to transfer their Bitcoins or cryptocurrency across to other users, and these days, as I had mentioned, you don't even need to bother entering their public key. All you need to do is scan a unique QR code that is present as part of their blockchain wallet, and the complete transaction happens right away. Apart from that, healthcare is a domain where blockchain is presently being used to store the details with respect to the patients. Now this ensures that anyone who has access to this blockchain can access the details of the patients as such. So imagine what would happen if we had a nationwide blockchain with all the details with respect to the patients. Since it's highly secure, no one can directly access this detail and make any changes with respect to it, thereby ensuring the anonymity of the patient. But at the same time, let's say a doctor wants to see the details with respect to a patient, all he needs to do is give him his details, give him his public key, through which he can access the complete details present on the blockchain and get the required data with respect to that same. Similarly, law enforcement agencies are using blockchain to ensure a highly accessible database comes up with respect to the criminals and the crimes that they have committed. So this is something that you can see coming out quite soon. Then coming to the election and voting domain. Now this is something that is a domain that is getting revolutionized with blockchain. We possibly might see the next or the next to next election made quite easy as well as secure and fail-proof with the blockchain system. Apart from that, Internet of Things is another major domain that is currently using blockchain system to ensure the transfer of data between the devices without any corruptions as well as without any interference as such. Online music market is something that is rapidly growing to the blockchain system as well. Here what is happening is that the music domain is completely changing and putting up its music on the blockchain, wherein anyone can have access to it but at the same time cannot make any modifications with respect to that. So let's say there's a specific customer who has paid for the song, then all I need to do is give him the details and he can take it from the blockchain as well. Apart from that, real estate domain is also being influenced by blockchain, and pretty soon I'm quite sure that you will be buying your properties directly off a real estate blockchain as well. Now, talking in detail with respect to the banking domain, blockchain has the possibility of cutting down $20 billion that is mainly taken up by middlemen. Now, this $20 billion is something that these middlemen organizations earn with respect to a year. Yes, although it does increase a chance of reduce of job with respect to these domains, but at the same time, imagine what could happen if banks themselves would implement blockchain. And that's exactly what they are being doing these days. And apart from that, the opportunity of hacking into the bank ledgers and making changes with respect to that same is becoming highly impossible as well for the people. Imagine what you would have done earlier was you would actually hack into a bank, make the changes in the ledger, take money from someone else's account, put it in your account. But now it's quite impossible because the only details that are present as part of the ledger is the transaction details, which as you know cannot be modified by a single person because the blockchain is designed as such. Also, it solves the problem of double spending. As we have discussed and seen how the double spending problem gets solved, this is something that can be quite useful for the digital banking domain system. Finally, talking about the risks involved with respect to that same. Since you have an idea of what is happening with respect to your money, you get a clearer idea as well. Rather than the conventional private ledger system that has been followed earlier, the next generation of distributed ledger system helps the people get certain clarity with respect to how exactly is their money being transacted and where exactly is their money at the moment. Although it again, as I have mentioned, maintains anonymity but gives you at least a clearer picture with respect to that same. Now apart from this, the payment and transfer domain is completely changed. Because of the security feature that is being provided by blockchain, this becomes a highly essential factor ensuring the ease of usage. Now, Bitcoin is basically a system that runs on no transaction fees. Again, let's say if you do want a transaction to be completed on a very high priority, then it's up to you to add a specific transaction fees. Why would anyone add a transaction fees if you don't have to add it? There are about 1 million transactions happening. Now, a miner needs to validate them. Even though there's a huge number of miners, it's not easy for him to verify all the transactions that come in at the same time. So what he's going to do is that he's going to see if there's any incentive added or any transaction fees added as part of this verification process. So if there is a specific transaction added, then definitely he will pick up the transaction first rather than a transaction which does not have any transaction fees attached to it. So let's say there is a real-time transaction that you're doing. It's a very huge amount and you need it to be completed immediately. Then what you can do is you can attach a certain transaction fees to that. And this will ensure that your transaction is on a priority when compared to other transactions which do not have a transaction fees attached to it. This is another way how miners actually make up some amount of their own while they are investing their resource. But again, this does not mean that those transactions which does not have a transaction fees attached to it does not get verified. As I had mentioned, in the process of mining for a new block, most transactions do get added to the ledger and a new block gets created accordingly. So only if a new block is created, then do they get rewards. And to create a new block, they need to add transactions as well. So trust me, all the transactions do get through. Apart from that, you don't need any specific bank accounts that are required. You don't need to link your bank account to your Bitcoin wallet. You don't need to give the complete details. You don't need to attend to annoying calls that you get from banks and so forth. Apart from this, your anonymity is completely maintained. Now, as I have mentioned earlier, you're basically providing the public key as part of the ledger. Now, there is an upside and downside to it. The upside is that no one really knows who's the person who has the most balance or how much balance does each person have who's part of the blockchain. But at the downside, all of you do remember the ransomware attack. There what had happened was they had requested in terms of bitcoins and they had given their public ID. Now, even though the public ID was provided, it is not easy to identify who the person was at the other receiving end because their complete details are hashed and hidden as well. So there's always a positive and negative to certain technologies as well. Apart from these domains, election and voting domain is one domain that is expected to change completely with the involvement of blockchain. Using the blockchain, you can always authenticate the identity of everyone who's voting using their signature as well as secure their personal information. Now, this ensures that we are not quite sure who exactly has voted for which party, but at the same time their personal information is valid and is highly secure as such. Now, apart from this, it ensures that there's no vote frauds that happen as well as the loss of record does not take place. Now, as I have mentioned, any transaction that gets added to the blockchain becomes a permanent part of it. And you cannot modify it, thereby ensuring that voters fraud does not happen or any other kind of foul play does not take place. Now, this in turn is going to lead to increase in turnout because everyone is sure that no one is going to know about their votes. There's no tampering that's going to happen, as well as it becomes easier for people to become part of this blockchain and submit their votes. Now, this in turn is going to increase the voters turnout as well because there are certain organizations that are investing resources to build an application itself which makes it easy for people to vote from anywhere that they are. Wouldn't you like to vote for your party sitting at home or working from your office, making it sure that you have cast your vote, you have made your decision, you have supported for your party. At the same time, the details are not leaked and at your convenience as well. Now, one of the popular organizations working in the voting domain is Follow My Vote. They presently are trying to change the upcoming election ideas and trying to implement the online blockchain voting system by maybe the next or next elections as well. So hopefully let's keep our fingers crossed because I would definitely like to be part of a blockchain system that takes my vote and helps me support my party as well. Now, these are just some of the most popular domains. Apart from this, blockchain is being used in different domains, and you have a lot of organizations who are coming in and investing in the blockchain technology as well. Now, to give you just a simple idea, some of you might have heard of the concept of Hyperledger. Now, this basically is a cross-industry collaborative effort from the Linux Foundation to support the blockchain distributed ledger system. Apart from that, organizations like JP Morgan and IBM are investing a lot of resource to build a public blockchain and increase the awareness, at the same time making a profit out of it sure. So again, blockchain is not something that is restricted only to the banking domain, because implementing a blockchain system is not very hard. It's quite easy. All you need to have is fundamental knowledge. Now moving on, let me help you understand how to work with a blockchain with our demo for today's session. Now, the demo that we'll be performing today is going to be using Ethereum. Ethereum basically is an online open source publicly distributed blockchain system to which anyone can be a part of. It's similar to your Bitcoin system itself. Now, what we need to achieve as part of today's demo is that we need to implement a digital bank which actually implements the Ethereum blockchain. Now, this system has to allow us to do three things. First is make cryptocurrency with a fixed market supply and token that represents real world value. That basically means that we need to create a cryptocurrency which has a fixed value outside. Apart from that, we need to autonomously create a private blockchain as well as mine for new ethers while validating the transactions. So if you're validating a transaction and creating a new block, you need to ensure that ethers are being provided to these miners as well. Okay, so let's not waste any time. Let's first begin by installing Go Ethereum onto our system. Then let's register an account to Go Ethereum blockchain. Then we'll be creating a private autonomous blockchain, and finally we'll try to perform few transactions internally. Now, as I had mentioned at the start of the session, these are basically dummy transactions that we'll be working on. But again, this should give you a complete idea of how a blockchain system works and how it effectively solves your problem. So first, let's begin by installing blockchain onto our system. Now, for this, the first thing that we need to do is that we need to clone the Go Ethereum path that is present on the GitHub repository, and we need to create a local repository as part of it. Now, we'll be doing that on an Ubuntu virtual machine. So in case if you do have an Ubuntu virtual machine to your access immediately, you can go on and try it out simultaneously as I do. Or even if you have Ubuntu installed on your system, I would recommend that you try it out. So we're going to go step by step, and I'll be explaining it to you completely. So even if you face any challenge at one step, I'll be able to assist you with respect to that same. Okay, so first let's begin by cloning the Git repository. Now the first thing that we're going to do is we're going to execute the command git clone, and then we're going to clone the Go Ethereum repository present on Git. So for that, use the command git clone. Now this may take some time, so I request you to be a bit patient while this command gets executed, because the Git repository for Go Ethereum is slightly big. Okay, so now that the repository has been cloned, let's go into the folder. So use cd go-ethereum, and let me show you the files that are present here. So these are all the files that are present in the Go Ethereum folder. So now what we're going to do is that we're going to check out the tags or the versions which are present for Go Ethereum. For that, what you can do, you can check the commit issues. So this will give you an idea as to the different versions of Go Ethereum that are present. So you can use the command git tag, and you can see the different versions of Go Ethereum. Since 1.6.7 seems to be the latest version, we'll use that as part of our practical. Now what we're going to do is that we're going to create a branch of the version 1.6.7. For that, you can use the command git checkout tags / the version which you want to branch. So in this case, it's v 1.6.7 followed by -b branch and the target destination. So what I'm going to do is that I'm going to set the target destination to be as Edureka Ethereum v 1.6.7. Let me just increase the size. Now let me just show you the branch. For that, you can use the command git branch. Now before we move forward and begin the blockchain execution, you need to install the Go language as part of your system. Now to do that, what you can do is that you can go to the website. So if you search for Golang download, you can be directed to the official download page for Go language, and you can choose whichever package meets your requirement. If it's OS X, if it's Ubuntu, if it is Windows, you can choose correspondingly and install Golang. Now since I am using a 32-bit Ubuntu version, I have downloaded this package. Now it's time for me to extract and install it as part of my system. To do that, let me just open a new terminal. Let's maximize this as well. And here, let me go to my home directory where the file is present. So by default, it would be stored in your downloads. So I recommend that you open a new terminal and ensure that the package is present into your home directory. So this is the file that I have downloaded. Now it's time to extract this. So for extracting and installing this file, you'll use the command sudo tar -xbf, following which you'll specify the file name. Always ensure that you're extracting the correct file. So the name of file is go 1.8.3 linux-386. Now if you're using a 64-bit, the file extension may change. Now once you specify that, just hit on enter and the extraction and installation will start. But before that, always ensure you're using the sudo command to execute this, because this requires administrative privileges. Now as you can see, the Go language is getting extracted and installed onto my system, and it has successfully extracted it. Now what I need to do is that I need to move it to a specific location, that is my /user/local. This is mainly to ensure that I have ease of access to this language whenever needed. So for this you can use the following command, that is sudo move go, that is the folder to which it has been extracted to user/local. Now make sure that you execute it and the file would have moved. Now just to check if the file is successfully moved, you can go to the directory, that is cd/user/local, and check if the file is present here. Sorry about that. So here you can see the Go folder is present. Once you've done this, just close this terminal. Now before you finally complete and execute this, the last step that you need to do is open a new terminal, and here you can try the command sudo.getit.bashrc. Now this is mainly to add the environment variables to my list of variables. So here there are 3 lines that you need to add. First is export go root is equal to the location where go variable has been moved to. So once you set the go root, then what you need to do is that you need to specify the working folder. For that, what you're going to specify is the go path variable. So for that you can use the following syntax, that is go path is equal to my home directory /project/project1. Now this can be set to any location as per your requirement. I'm just setting it as to the following. Finally, what you need to do is you need to add this to your path list. So the command is going to be the following: path is equal to the syntax that has been specified here, that is go path /bin : go root /bin : path variable. So once you do this, you can save your bash.rc and close it. Finally, use the command source.bashrc to ensure that the bash file gets restarted. Now to check if the Golang has been installed successfully, just execute the command go version, and you can see it has successfully been installed. So let's close this and let's go back to our Go Ethereum terminal, and here what you need to do finally is that you need to execute the make all command. Okay, sometimes this tends to happen, so what you can do is just close this, open a new terminal. Let's go back to our Go Ethereum folder, and here just check the Go version. Yes, this is working. So sometimes what happens is an existing terminal does not accept the updated value. So in that case, just open a new terminal and execute the following command. So now the final command that we need to execute is make all. So here just execute make all. So as you can see, it's getting executed. So what it does is that it basically tells Git to build the target file as per the input with respect to it works. So again, this may take some time, so I request you to be a bit patient. Great. So with this, we've completed the first phase of our demo. What we have successfully done is that we have successfully cloned the get code from the Git repository. Now the next step is to create a Genesis block. Now what exactly is a Genesis block? Genesis block is always referred to as the first block or the 0th block for a blockchain. It basically contains the details with respect to the blockchain. So what we'll do is we'll first begin by creating a Genesis folder, and then we'll add a Genesis JSON file into it. So what we'll be doing is in our Go Ethereum directory, we'll be creating a new folder called Genesis. Now let's go into the Genesis folder. And here you need to create a new JSON file which has all the details of the Genesis block. So for that, use the command get it Genesis, and I'll just name it genesis3.json, and let's add the code. Now what has to be present in the Genesis block? Let's discuss about that. Now in a Genesis block, you define the different rules for our blockchain. So for that, what you have to do is you need to understand this code. So let me just give you a brief summary as to what is present as part of this code. Now let's start by the simple things. Timestamp basically is a timestamp, and extrabyte basically is the extra 32-bit memory that you can use to pass any message with respect to that same. Then comes difficulty. Difficulty basically is how difficult is it going to be to mine a specific block as part of the blockchain. So you can set this difficulty and modify it as per your requirement. Then coming to Coinbase. Coinbase is basically the address to which the coins have to be sent to after the block has successfully been mined. Then comes your parent hash. Parent hash basically is the hash code of a parent. In a blockchain, every block has the hash code of the previous block, and this is how you identify which is a valid block or not. So in our case, we are setting the value of parent hash as well as Coinbase to 0, and now we'll talk about both nonce as well as the mixed hash value. A mixed hash value is a value that is kept fixed throughout your blockchain, but your nonce is the key value that needs to be computed by every miner. Okay, the combination of your nonce as well as your mixed hash is something known as a proof of work. You need to get a specific hash value with the combination of nonce and mixed hash, which is less than the set value for a block. How is this value defined? There's a certain mathematical logic associated to it. So let's not go there now. Basically what you need to do is that you need to identify the value of nonce. Once you've identified this value and added it to the mixed hash, it should be equivalent or lesser than the mathematical value set for that block. Now this is where the resource gets invested. The value of nonce is something that you get by trial and error method. Now it was believed that in the year 2014, the value for nonce had to be tried between 1.4 till 15 quadrillion values. So you can understand how much effort it takes. This is exactly why I said one block cannot be completely solved by a single user and requires a lot of computational power by a user. And this is why in today's world, most miners come together to form a pool where the work gets distributed among them. They try out different values accordingly, and once the block gets solved, the incentive gets distributed among the people involved. So I hope this has also given you an idea as to what is the role of a miner as such. Okay, so two things that we're left out with is gas limit. Gas limit basically is the limit of gas or resource that you can spend while mining a block. What happens if too many people invest too much of resource? Then it becomes easier for them to mine the block. So there's a certain limit set for that. So that is what exactly is your gas limit. And finally, alloc is the last command that you have here. This is mainly used to define a list of pre-filled wallets. Now, since we are not using pre-filled wallet system, we have left it empty here. Great. Now let's add this code as part of our Genesis block. Now I've also shared it with you, so make sure you're doing it simultaneously. So let me just add it here and save it. So once you've completed this, we are done with step 3. Now it's time to initialize our blockchain. So for that, let's go back to our presentation. Now for starting your blockchain, you need to execute the following command, that is home/edureka/go Ethereum. Now Edureka will be replaced by the user that you have specified. Then inside the Go Ethereum, you need to go inside the build, bin and get, and there you need to specify the data directory which is of the Genesis file. So that is Ethereum net3 init genesis3.json. So let me just execute this. Now let's go back to our home directory, and here let's execute the command that I have just shared with all of you. Now this command will help you start the Go Ethereum blockchain. Great. Now that we have initialized the blockchain, it's time that we get the get console access. Now the get console is important because all the commands that you need to execute as part of the blockchain are commands that get executed on the get console. So for that, we'll use the following command, where the only variation is with respect to the network ID, where you have previously initialized the Genesis file. Here you need to use the network ID 3 console. Once you've done with this, you get direct access to the get console, where we'll be executing certain commands. So as you can see, the get console is getting initialized, and here you have the get console initialized. So now let's discuss about the various commands that we're going to use as part of today's session. So we need to create new account as we had discussed as part of the problem statement. We need to check the balance. We also need to mine and check the wallet balance of each of the miners. So for that, let's go back to the slide and discuss each one of them one by one. Now the first command that we need to execute is personal.newAccounts. Now this creates a new account as part of your blockchain which has a specific wallet attached to it. So every time that the blockchain mining happens, the wallet gets updated with respect to the Ether value. Apart from that, the next command is eth.accounts, which will help you check the various accounts which are part of the blockchain. Then you have eth.block number. Now this helps you identify the total number of blocks which are part of your present blockchain. Then you have miner.start. This starts the mining operation, and to stop the mining operation you can use the command miner.stop. Finally, you have eth.block number, which tells you at which block you are after performing the mining operation. And finally, the command that is eth.getBalance will help you identify what is the balance in a specific account. Now this is basically the account details that we had seen earlier. It is a hash value and you get it as soon as you create an account. So now let's go back to our console and begin by executing each of these commands one by one. Now as we have discussed, the first command that we'll be executing is for creating a new account, so that is personal.newAccount. Now one thing to remember is that A is capital here, and once you hit on enter, it asks you for a passphrase, which is quite similar to your password. So once you set a specific passphrase, it will ask you to confirm it again. Once you've entered the passphrase, it begins the creation of a new account and you get the account number added here. Now let's see which are the accounts as part of your present blockchain. So for that, use eth.accounts and it will give you a complete list of all the accounts part of your blockchain. So I have been using this blockchain for a while, so there are different accounts which are part of my blockchain. So since you are creating an account for the first time, you'll just have one account. I'd recommend that you create 2 accounts at least before you go ahead with the next step. So you just need to execute the previous command, that is personal.newAccounts, to create the second account as well. Let's check on which block I am at present. So for that, use the command eth.block number, and here remember n is capital. So once you do this, you get the value of the block number. Now I am at 3326 because I have already used this operation before, but you may get the value as 0 because you might be on the 0th block. Okay, so let's start our mining operation. For that, which command are we going to use? That's correct, Aditya. We're going to use miner.start. Now once you do this, it may take certain time for the resource to get allocated and the mining to start, so I request you to be a bit patient. And what we're going to do is that we're going to execute this mining operation for the next 10 minutes and let's see how it goes. So as you can see here, the mining operation has started and we are mining newer blocks as well. So let me run this operation for the next 10 minutes and let's see how it goes. Okay, so now we have run our mining operation for 10 minutes. Let me just stop this. So for that, we are going to use the command miner.stop. And once you execute it, if you get true, that means the mining operation has stopped. Now let's see which block we are presently in. So for that, which command do we have to use? That's correct, Deepika. We're going to use the command eth.block number. Now if you can see, we are at block 3367. Who remembers the first block before we started the mining operation? Yes, it was 3326. So we've mined close to 41 blocks in just 10 minutes. Now this is because we have set a specific value of difficulty. If you want, you can increase it. You can change the value of that, thereby increasing the time for mining a block. So I request that you try that out by changing the values in the Genesis blocks. Now it's time that we go to the last step, that is to check the balance of an account. Now let me just see all the accounts that are part of this blockchain. So for that, we're going to use the command eth.accounts. Now to check the balance, you need to use the command eth.getBalance. Again, here B is capital. And here you need to specify the account number. So let me just pick the first account number here. I'll copy it and pass it as a parameter for my getBalance function. Now when you hit enter, you can see the corresponding value of Ether that is present in this account. Now since this was my first account, it has a certain specific value. Now the more time that you run your mining operation, more will the Ether get created and added to these accounts. Now, if you see newer accounts, they may not have the same ether that are present there. It gets distributed according to how much resource has been put in by each miner. In this case, the first account has been there for longer time. But if you see the latest account, if I execute this, then you see the balance to be 0 because it has not contributed that much as part of this block. So I would request that you try mining it for a while, maybe try mining about 500 or 600 blocks, and then you can see the difference with respect to the latest account that you have added. Now, coming back to our presentation, with this we come to a conclusion of today's session. Just to summarize what we have learned, we started off by understanding what would a world look like without banks. We even saw the Bitcoin history and how blockchain helps with the Bitcoin solution. After that, we talked about the various blockchain concepts and the blockchain use case, and finally we saw the demo as part of today's session. Happy learning. Thank you.
Hi folks, my name is Arya and I welcome you all to this video on blockchain applications. So this is going to be one of the most preliminary videos in the blockchain application development playlist. And in this video, I'll be explaining how the development of decentralized application actually takes place. And then in the end, we'll be going through some of the most popular decentralized applications that are using blockchain tech. Okay, so let's get started. So first of all, we're going to be taking a look at the traditional way normal applications or web services work. So firstly, a web service has two parts. Firstly is the client, and then the client connects to the web server. Now this web server is very centralized and it's owned by a certain company that is actually hosting all the web services. So anytime you want to use any of the services hosted by this particular company, you have to send a request to their server, in which the response they will give you the requested service. Now, what does this centralized server actually contain? Well, it contains two major things. Firstly is the API, and secondly is the data. Now, the API is mostly all the services and all the endpoints that are actually being served by the hosting service. That may be any company like Facebook, Google, Twitter. And the second part is the data part. Now, this is the most important part for you as a user, because any of the data that you are also creating, that is user-generated content, is also being stored on their centralized architecture. So what does this actually mean? Well, when these two things are actually being owned by big major companies, they have the right to do anything with your data. So however, they may be advertising your privacy protocols, like Facebook says that they will never use any of the user-generated content for their own business. But that's kind of not true. Facebook earns a lot from ads that is actually being directed towards you because of the interest that you show on Facebook. So if you show some interest on clothing, you'll definitely get some ads related to clothing. So how is that not using user-generated content for their own purpose? Well, some of you might not agree with this whole agenda of privacy and how it works. Well, you don't actually need to, because the main problem out here is that it's a central point of functionality. So if a hacker actually wants to penetrate through to their system, he only has to actually concentrate on one point, and that is the main server. So if that is actually hacked or somehow compromised, all your data, all the APIs and all the endpoints, everything is compromised in a process. So this is how traditional applications works, and these are the shortcomings that comes with the traditional applications. So the invention of decentralized applications mostly promised to deal with all the problems that come with the centralized architecture. So let's see how a decentralized application actually works. So firstly, you have the user who invokes a smart contract. Now, if you don't know what a smart contract is, you can check out my smart contract tutorial, where I've told you all everything that you need to know about smart contracts and most of its development part. Now, the smart contract will contain all the rules abiding for the service that is being provided, and it also contains state information which contains data for the smart contract. Now, you must be also thinking that in a centralized architecture, the hosting and other peripherals is taken care of by the hosting company like Facebook. So when you are going on Facebook server, you do not actually have to pay for any computation because Facebook is doing that already. Now, Facebook also takes a part of your money and now Facebook also takes a part of your data and converts it into more profit, but that exactly doesn't really happen in a decentralized network. So how is computation being paid for in a decentralized network? Now, the computational resources that is required, it is paid in gas, which is the unit that is used in the Ethereum network. I'm going to be using the Ethereum network for per se as an example. So gas is the way you pay for resources when you are using a decentralized network. Other than that, you're also paying a small amount of fee called a transaction fee. Now, this transaction fee is actually collected by the miners who are validating these blocks. This transaction fee can actually vary from around 1 or 2 Ether or even its smaller denominations. Now, every miner who validates a block also gets paid by the network in terms of Ether. So every miner probably gets around 1 to 2 Ethers nowadays. And every block takes only 14 seconds. So that's how currency is also being generated in the network. Now, what happens next is all this money that you need for your transaction is being fetched from your wallet, which is your Ethereum wallet. Now, your Ethereum wallet is used to manage your funds and invoke different contracts. So that's all you need to keep in mind when a wallet is told to you all. Now, after all this invocation has been done and all the state changes have been made and the miner validates the block, all this information is then sent to the network, and the network then updates your wallet with the new and updated funds that you have. So this is basically how a decentralized application works. You are going to invoke a smart contract. Now the smart contract changes some stuff on your account, and all these resources that you use are paid for you and by the network itself. So you're basically not depending on anybody else. Now let's see the technology stack that is normally used in the development of decentralized apps or dApps. So the front end is made mostly using the normal way, that is HTML, CSS, and JavaScript. But you can also use any of the majorly available frameworks like Angular, React, Vue.js to actually create your front end, because your front end will be interacting with the smart contracts through the Web3 API. Now, the Web3 API is what lets you connect to the smart contract that is residing on the decentralized network, and the decentralized network can also talk back to your application through the means of events. We'll be talking about events when we get into the app development part in future videos. But for now, all you need to know that smart contracts are written in Solidity, and the front end is written however you want to wish, actually. Now, Web3 is available in JavaScript, Java, Go, and Python. And we'll mostly be referencing the JavaScript part, that is the web3.js. So we'll be using web3.js when we're actually developing some kind of app in the future. So don't forget to check back in. Now, let us just go over the advantages of decentralized applications or blockchain applications that come along with it. So firstly is autonomy. So it's autonomous because you're the one making the agreement. There's no need for a broker or a lawyer of any sort or any sort of third party for that matter. Secondly, there's a lot of trust because all your documents are encrypted using modern technology and modern encryption methods, and it's all sharded and distributed on a decentralized network, which is being run by a shared ledger. So there's literally no way anybody can break into it, now at least, unless quantum computing becomes a very big thing in the next 6 months or something. Thirdly is backups. On the blockchain, your documents are duplicated many and many times over. Your documents are owned and seen by everybody on the internet, but in an encrypted fashion. So you do not need to worry that, oh, somebody has my copy, so they might be able to see it. It's not like that. It's all encrypted and only you can see it. But a copy does exist. So in case you actually lose some of it, you can always go back and check your transaction IDs and get back what you just wanted. Last but not the least is accuracy. Now, whatever these smart contracts are trying to replicate, so things like bidding, form completion, and such things, mostly done by clerical workers. So most clerks actually tend to make a lot of mistakes because this work is generally very tedious manual work. But since we're talking about computers, there is no chance for any sort of mistake unless there's bad code, in which case it's normally a bug which is fixed by the developer in no time. So accuracy, backup, trust, and autonomy. These are the major advantages of decentralized applications that is severely lacking in most centralized architectures. So now that we've seen how decentralized apps work in comparison to traditional apps and the advantages of using a decentralized architecture for most service providing apps, so let's go ahead and see some of the most interesting decentralized applications or applications running on the blockchain that have been developed till date. So firstly, we have Block Verify. Now, one of the most significant problems that the business community faces globally is counterfeit products. These counterfeit goods and products lead to billions of dollars in losses every year. However, the blockchain could offer a solution to these issues. Block Verify is a project that seeks to harness the blockchain to fight the counterfeit industry. With the blockchain, BlockVerify is confident that they can monitor the entire supply chain with complete ease. According to those behind BlockVerify, the only way to improve anti-counterfeit efforts is to utilize the blockchain. To achieve this, they are using a private blockchain which is highly scalable, transparent, and tamper-proof. Every product will be given a unique identification number that is then stored on the tamper-proof blockchain. So basically, BlockVerify can help you identify counterfeits, non-duplicatables, company verifiables, and it also offers a global solution in the method. Now anyone can be able to access this number on the blockchain to verify whether a product is genuine or not. So with the solution, things such as medication or anything else can be verified with ease using this solution. Anyone can be able to conduct the verification utilizing this technology. So what all can BlockVerify do? Well, it can help you identify counterfeit goods or diverted products or stolen merchandise and even fraudulent transactions. Okay, so that was all about BlockVerify. Moving on, we have Ripple. So RippleNet is a network of institutional payment providers such as banks and money service businesses that use solutions developed by Ripple to provide a frictionless experience to send money globally. So let's give an example first. So firstly, imagine there's a Mr. Jones who lives in New York and has a box of chocolates that he doesn't really need. Now he's very interested to watch a baseball game but doesn't have money for the tickets. Secondly, there's a Mrs. Smith who lives in Los Angeles and has a rare stamp and she would like to give away for a box of chocolates. Lastly, we have a Mr. Brown who lives in Alaska, suppose, and he's looking for a rare stamp and he has a ticket for a baseball game in New York that our Mr. Jones is very much looking for. Now, in our current system, these people would probably never find each other and remain with their not valuable valuables. But in the Ripple world, they could say, hey, I have a box of chocolates and I want baseball. And the system will look for a shortest and cheapest combination to make it happen. Moreover, the platform allows you to make payments in any currency, including Bitcoin, and has a minimal internal transaction commission of around $0.00001. Yes, that's the right amount of zeros I just said. And the only reason it's not free is to only prevent DDoS attacks. So the current system for transactions is pretty much unreliable, expensive, and slow. Unreliable in the sense that a transaction can take days to actually get committed to the bank. It's expensive in the process as to how many people you need to pay to get your transactions done. And it's very slow as a whole overall. Now, what Ripple does is it promises to actually remove all this by making transactions very much accessible. Like I just said, that you can exchange cookies for a baseball game, something like that. And it's very, very fast. Oh my God, Ripple is amazingly fast. You have no idea how fast Ripple can be. Secondly, because it runs on the blockchain, of course, it's reliable. And as I just said, Ripple has some insanely low costs. And it's only not free and low cost because we need to prevent those DDoS attacks. Up next on our list of blockchain applications is Storj. So Storj is an open source decentralized file storage solution. It uses encryption, file sharding, and a blockchain-based hash table to store files on a peer-to-peer network. The goal is to make cloud storage faster, cheaper, and private. Now, the traditional cloud storage solutions like Dropbox or Google Drive has limitations. While files are backed up redundantly, bandwidth from a data center or unexpected outages can restrict access to your files. There's also this issue with privacy, and these companies have control over all your files, including the ability to access them. Now, the Storj project uses blockchain and peer-to-peer networks to solve these problems. It distributes the files so redundancy is well established. It also guarantees you're the only one who can access the files because of the encryption. Now, the best place to understand Storj is probably torrents. Now, in the near early 2000s, torrents became a notorious way to download movies, music, TV shows, and use them for free and illegally, of course. Now, torrents use a peer-to-peer network, and it works something like this. Mainly, users maintain copies of the same file all over the network. When someone wants a copy of that file, they send a request to the peer-to-peer network, and users who have the file known as seeds send fragments of the file to the requester. The requester receives many fragments from many different seeds, and the torrent software recompiles these fragments to form the original file. Now, the benefits of using a torrent is you can download fragments of a file from multiple sources in parallel. So this means the file transfer could potentially be faster than the downloading and the whole thing all at once from a single source. Additionally, for the purpose of pirated music and videos, torrents are decentralized. No company controls the torrent, so it's difficult to shut down a torrent. And the same could be said for Storj, but you can't say the same for Google Drive. So Storj works in a similar way, except it's not for pirated music and videos. So let's take a moment to understand that. Firstly, there's some end-to-end encryption going on. This is where the data privacy goes to the next level. Sharding already adds one layer of privacy as no one knows which data to host and can read the whole file from, but even being able to read a shard of a file is problematic. It could still contain some sensitive information. So what exactly is file sharding? Well, the first way Storj is similar to torrents is sharding. So this means your file is broken up into millions of pieces and distributed on a network. So that is where the distribution part comes in. And the fourth part is audit or file verification. So to answer this concern, Storj completes a file verification audit every hour. In order to get paid, farmers or the people who are validating on the network have to prove that they have the shards they've been sent. Storj sends a request to the farmers, and if the farmer has changed or deleted the encrypted shard, they won't be able to answer the request. So that's a pretty neat way to actually approach cloud computing and cloud storage using blockchain applications. So next up on our list of blockchain applications is Auger. So Auger is a decentralized prediction market which can forecast the outcome of an event based on the wisdom of the crowd principle. So basically it's a prediction market protocol owned and operated by the people that use it. So with this method, information collected from the crowd is averaged into the most realistic possibility and therefore the most probable outcome. Correct predictions are rewarded by the network while incorrect reported and penalized. And this incentivizes the truthful reporting of events. So Auger aims to revolutionize the prediction market and in doing so, changing the way people receive and verify the truth. Now the main idea is to make more accurate predictions by large groups of people rather than a small team of experts. So Auger is also the first major decentralized application developed using Ethereum and represents a major proof of concept for this underlying technology. Decentralization ensures that Auger cannot be censored by governments that deem prediction markets as gambling, whilst ensuring the sustainability of the application. This decentralized nature ensures honesty in reporting an outcome of events using crowd wisdom to cancel out individual frauds. Now, Auger has been used for weather prediction, political forecasting, event hedging, and even company or business forecasting. And it's going pretty well in my opinion. So how exactly does Auger work? Well, Auger works on events. So an event occurs that is being wagered upon in a market created on the Auger network. Now, the outcome results are reported by the reputation holders to Auger in two steps. Part one of this step is the reputation holders privately and securely submit outcome results to the network. And the part two is that about 1 month later, a second report is publicly submitted in plain text for all to see. Next, upon completion of reporting periods, consensus is achieved, leading to two financial events. Those who wagered correctly are paid out for their predictions, and honest and active reporters receive trading fees and proportionate with reputational holdings. And on the other hand, dishonest and negligent reporters lose a lot of their reputation points, which is redistributed to honest and active reporters. So this means that rep is only necessary for those wishing to report and not for those just wishing to wager. So all reputation tokens are available in the reputation software sale, and you can check them out at Auger's site. Now, the last application that we're going to talk about is going to be something for you guys who are looking for jobs. So firstly, this is called Etlance. Now, Etlance allows you to create an employee or employee profile and list and apply for open positions, ranks, and provide feedback for employers and employees, and send and receive invoices. Now, Etlance works on the Ethereum, and so it basically has 0% service charge, is decentralized, and there's no restriction, and has free membership. So something like freshersworld.com, where you are applying for jobs as a fresher, you mostly have to pay a certain amount of fees so that you get those invitations and interview call letters. But on Etlance, you basically don't pay anything, and you are getting the best contacts as a freelancer. So basically, Etlance is a first of its kind in the job market platform for connecting freelancers and developers with employers. Its database runs completely on the Ethereum public blockchain, and front-end source files are distributed on IPFS, or the Interplanetary File Storage System, meaning Etlance is fully decentralized. So basically, there's no cuts and only savings. Etlance doesn't take a percentage of what you earned from the connections that you made on Etlance. And the amount of ether that the employer pays is the amount the freelancer gets. So that's a very, very big thing for freelancers. Next is there are no artificial costs or restrictions. For example, let me just quote Freshers World. So Freshers World says that you can join for free and you'll get all those interview letters, but that's actually a sham because you will be needing to pay that really pro version payment option that they have. So you will have to buy that if you want to get those premium companies calling you for your CV, even though you might be actually a very good coder. So basically everybody can apply for a job on Netlands or create an unlimited number of jobs. All that is needed is to pay for the gas fees that is associated with these operations. Okay guys, so in the end we saw how decentralized applications are developed, the technology stack that is used, basically HTML, CSS, Web3 API, and Solidity, and how decentralized applications compare to traditional applications. And then we saw a few very good examples. That's going to be all for now. Goodbye and have a good day.
Hello everyone, this is Neil from Edureka and welcome to this session on Blockchain Wallet. Now without wasting any time, let's move forward and look at today's agenda to get a better understanding of what we'll be covering as part of this session. Now the first thing we'll try to understand is why do we actually need a blockchain wallet as such? Okay, when there are different types of wallet present there, why do we specifically need a wallet that stores our bitcoins? Moving on from there, we'll talk about what exactly is a blockchain wallet and we'll look at the various features of a blockchain wallet. Once you've seen these features, we'll talk about the various types of wallet that are present in today's market. Now there are different types of wallet that are available today. So we'll compare some of the most popular wallets and help you get a better understanding as to which meets your requirement. Now I hope you guys are definitely excited for today's session. So let's move forward to today's first topic, that is why do we need a blockchain wallet? Now first thing that comes to your mind is why do we need a specific Bitcoin wallet? Now again, what you need to understand is that Bitcoin is a digital cryptocurrency. So to handle these cryptocurrencies, to store them and as well as manage the transactions, initiate the transactions as such, you need a specific type of wallet. And that's exactly what your blockchain wallet is. Now apart from that, most people usually have multiple blockchain accounts. Okay, so each account correspondingly could have a different amount of Bitcoins present in it. Now this is a general policy most people actually follow. Now in that case, using the same blockchain wallet, you can store all these accounts and ensure that you have complete access to your accounts as well as balance. Apart from that, these blockchain wallets in itself help you instantaneously perform transactions. Now once you have the address of the person whom you want to send the bitcoins to, then it's just a matter of copy pasting it, specifying the amount of bitcoins you want to send, and then just clicking on send. And the transaction in itself is quite instantaneous as such. Finally comes the concept of transaction. Now always it's important that you keep a track of all the transactions that you do. Now once you have linked all your blockchain accounts to a single blockchain wallet in itself, it becomes quite easy for you to keep track of all the transactions that you have performed. Now take an example of online wallet like Blockchain Info. Here all the transactions from when you have created your wallet are available. Now this basically gives you a complete idea of how much you earned, whom you've sent to what, as well as all the references and the transaction details as well. Okay, now moving on, let's try to understand what exactly is a blockchain wallet. It's basically similar to a bank account. Okay, like how you have a PayPal account, how you have a bank account associated with Bank of America, ICICI, HDFC, and so forth. Your blockchain wallet also is equivalent to a bank account itself. Here what happens is you use this specific blockchain account or blockchain wallet to send, receive and store your bitcoins as such. Okay, so again similar functions to your bank account itself. Now again, how it is different is that instead of actually sending currency, here you're sending bitcoins. But the value of bitcoins is something that is not constant. It keeps changing with respect to the current value of bitcoins as such. Now, more people invest into bitcoins, more will the value of bitcoins increase. More people pull out from it, more will the value reduce as such. Now, this is one of the major contributing factors that decides the value of bitcoins as such. Because the Bitcoin and blockchain system is something that's completely built on no trust model. You don't need to put your trust on someone else to understand. Now, we need to understand that here more and more people invest into the system, more and more will the value keep growing. And this is one of the greatest contributing factors for the growth of Bitcoin. It's grown over 650% at least in the past year itself. Great. Now, moving forward, let's try to understand the various features of a blockchain wallet. How does it separate it from the other wallets that are present in the market for storing digital currency? Now, the first and the foremost feature is the security feature. In comparison to most other digital wallets, blockchain wallets have multiple layers of security. Apart from that, even initiating a transaction involves certain levels of step. You're going to have to enter your PIN that is associated for the wallet. You may have to enter a passphrase if required. If it's a hardware wallet, you need to actually specify. You need to actually confirm the transaction on the hardware wallet and so forth. Again, in comparison to most other wallets out there, the number of security layers associated with a blockchain wallet is quite high as such. And apart from that, the blockchain system in itself is something that is completely built on various security techniques. So this ensures that even the transactions themselves are completely secure. But one thing you need to remember is that the transactions in a blockchain ledger are not reversible. That is, if you've initiated a transaction to a wrong person, then you cannot recover the bitcoins that you have sent. Always ensure that you're sending the bitcoins to the correct address. Apart from that, the next feature would be the instantaneous transaction feature. Now again, as I had mentioned to you, the transactions here are quite instantaneous. You don't need to wait for a long time for the transaction to complete or for a confirmation to come. Now if you work with bank transactions, there are times when you initiate a transaction but have to wait till the banking hours for the transaction to get completed and verified as such. But here the transaction can be initiated 24 hours and 7 days a week, and you don't need to even worry about the delay with respect to the transactions. Now, one major factor with respect to the blockchain wallet is that it lets you convert your bitcoins into different cryptocurrencies, as well as you can sell out your bitcoins into any currency that you want. Now, as for today's session, I'll be showing you how we can buy bitcoins using Indian rupees. Then I'll also show you how you can convert bitcoins to Ethereum on the blockchain info wallet. Finally comes the use of accessibility. Now, again, as I had mentioned, Bitcoin wallets are present in multiple platforms. Okay, you can have your wallet present on a piece of paper. It could be present on a hardware device. It could also be on your phone. So at any given instant, you have the complete access to your wallet, and it becomes easy for you also to check up your balance. You can also validate your transactions and immediately also initiate any transactions as per your requirements as such. Finally, let's move forward and talk about the various types of wallet that are present with respect to blockchain wallet. Now, it's essentially important that you understand the different types of wallet that are present so that you can go on to decide which wallet suits your requirement as such. Now, the first category of wallets are based on the location of the private key. That is, where exactly is the private key associated to your wallet being stored. Now, when we talk about a hot wallet, this is basically a blockchain program wherein the private key is completely stored on a cloud-based server. So you don't need to worry about where it's being stored, because what happens is it's present on the cloud, and anytime you want to access it, you can go on to the website of the blockchain wallet and immediately access it as per your requirements as such. The second type is called a cold wallet. Now here how it's slightly different is that you have an application that runs on either your device or it could be a hardware wallet as such. What you need to do is that all the transaction related details, that is the private key, the sender's key, apart from that the amount, everything is going to get first hashed, and only the transaction hash is going to get propagated throughout the network. So this ensures that the details with respect to the user is secure as such. Now in comparison to security feature, cold wallets are considered to be more secure than hot wallets because again you have the complete control with respect to your private key. But at the same time, in terms of accessibility, hot wallets are more easily accessible, as well as the speed of transaction with respect to a hot wallet is quite faster when compared to a cold wallet as such. Then you have based on the devices and clients. Let's first talk about the devices. You can either go for an online web wallet. Here what happens is the wallet is actually present online. That is, it's a web-based wallet wherein all your keys would be stored on a cloud-based server. Apart from that, you have mobile wallets. Now here what happens is usually the private keys are stored on your phone as well as it's linked to a web-based server. Now on the web-based server, based on the application, there would be a copy of the private key, or it could just be stored on your phone, whereas the transaction details would be propagated on the cloud service. Then you have desktop wallets. Now desktop wallets are basically an extension to your cloud-based wallet. But what happens here is that it is actually a cold wallet rather than a hot wallet, because all the details with respect to your private key, your transactions, everything is stored on the wallet and is not directly accessible to a third-party professional. Now again, you need to understand that all the details are present on an application. It's only the final hash value that is going to get propagated through the cloud-based server or on the blockchain server itself. Finally, you have physical wallets. Now physical wallets is something like your security mission. You can have your physical wallet either present in form of a Bitcoin card. It could also be a paper wallet as such, where you're storing your Bitcoins in a piece of paper. Okay, now this is a simple example of how a paper wallet would look like as well as a Bitcoin card. Now apart from that, physical wallets are also usually used to store Bitcoins for future purposes as well. So let's say you want to save up some Bitcoins in case of some emergency, physical wallets are one of the best choices as such. Now moving on, let's talk about blockchain wallets based on clients as such. You can either have a software client wherein it could be a desktop application, it could be a cloud-based application, mobile application or so forth, or you can go with a hardware wallet as such. Now again, as I had mentioned, it's based on the user's requirement that you can choose one or the other. Now let's compare some of the most popular wallets that are present in today's market. Okay, so we are going to compare 5 of these popular wallets and each of them come from a different category as such. Now the first wallet that we'll be talking about is Bitcoin Core. Now this was the core wallet introduced by bitcoin.org and is one of the most secure as well as stable wallet in the market today. What you need to understand is that while you're using this wallet, it completely downloads the entire blockchain. That is, you get the complete blockchain downloaded on your system. So thereby it becomes a very huge wallet. Given today's size, it's close to about 130 GB that gets downloaded when you're working with Bitcoin Core wallet. But with respect to the space and the memory constraint also comes the feature of security, privacy and stability with respect to it. So this is one of the most popular wallets that had been initially introduced. Coming on to the next wallet, that is Tensor. Tensor is again one of the most popular wallets as a hardware wallet. Okay, now again with respect to hardware wallet security, this is again one of the major players in the market today, and it also comes with respect to a display as well as 2 keys which will help you verify as well as adds another layer of protection for your blockchain wallet. Now again, when you talk about the security feature with respect to Tensor or any hardware wallet, it's very high in comparison to all other wallets. But again, with respect to ease of use, it's not that comfortable when you're on the go or when you want to immediately initiate a transaction. These are not very comfortable for that. Okay, coming down to the next wallet is Blockchain Info Wallet. Now, Blockchain Info Wallet is one of the most popular online wallets present today. It has close to about 8 million different users as such. Now, it also supports both Bitcoins and Ethereum and helps you convert your Bitcoins to Ethereum and vice versa, which we'll be seeing as part of today's demo as such. Now, apart from that, it also offers one of the cheapest transaction fees for initiating any transaction as such. Like, let me just give you an example. Let's say if you want to send about 2,500 rupees on a non-peak hour time, it costs you somewhere about 4 rupees as such as the transaction fees. And at the same time, if you want to make the transaction a priority transaction, the transaction fee slightly increases to about 41 rupees. Again, this is very small fees that gets included when you see the overall transaction fees with respect to the different forms of transactions that are available today. Okay. Next, we have Electrum. Electrum is again a very popular desktop-based wallet and is known for its security feature as well. Now, in terms of speed as well as simplicity, is one of the most popular ones as such with respect to desktop wallets. There are various features with respect to Electrum, so I would definitely recommend if you're looking for a desktop wallet, this is one that you should definitely put your eyes on. But again, one thing you need to remember is that Electrum has slightly higher transaction fees when you compare with respect to the other desktop wallets as such. Moving on, Mycelium. Mycelium is one of the most popular mobile wallets which is present for both Android and iOS. Okay, here you have the complete access to your private keys and it does not leave your device unless and until you wish it to. So as I had mentioned to you, this is an example of a cold wallet. Here the private key details are stored on your device as such, and unless and until you want it to be migrated, it does not get migrated. Now there are people who want to constantly keep checking their Bitcoin wallets for an update with respect to the value of Bitcoin. So Mycelium also offers you an option of watch only address wherein you can keep checking the value of Bitcoins associated in your wallet without having actually to log into your wallet as such. Okay, so I hope you've got a simple understanding with respect to the different types of wallets as well as the comparison between the most popular wallets in today's market. Now with this we come to a conclusion of this session. I hope you had a great learning experience. Thank you and goodbye.
Hi guys, this is Prerna from Edureka and welcome to this interesting tutorial on Ethereum. Now before we move forward, let's have a look at our agenda for today. So we're going to start by developing an understanding of what Ethereum is. Then we'll move on to talk about the types of Ethereum accounts, following which we'll see what smart contracts are. Well, these contracts have been made popular in the recent years due to their implementation in blockchain. After this, we'll learn about the EVM on which these contracts are executed. Then I'll also tell you how to practically deploy smart contracts on the Ethereum blockchain under a test environment. And towards the end of this session, we'll talk about the real-life use cases of the Ethereum blockchain. These are the decentralized applications and the decentralized organizations. Now, before we start with our first topic, let me just brief you on why Ethereum is needed. Well, most of you here might already be familiar with the Bitcoin blockchain. Bitcoin is the original blockchain entity for providing a decentralized system to facilitate peer-to-peer exchange of values. Ethereum, on the other hand, came up from the idea that blockchain could be used for a number of purposes beyond the bookkeeping of financial transactions. So we can also say that Ethereum maximizes the usage of potential blockchain applications. Now coming back to our original topic, that is, what exactly is Ethereum? So guys, Ethereum is an open source distributed platform that allows decentralized apps to be built on it with the help of smart contract functionality. It was developed by Vitalik Buterin as an extension to the original core blockchain concept. Let me give you an analogy. Think of the Ethereum network as a collection of decentralized and distributed vending machines. Now you go and you put in tokens inside these vending machines and then specify the action that you want to be taken by pressing in the numbers. Now whenever each number is pressed, a certain code gets executed inside the machine. These are the smart contracts. And then a service is provided to the concerned user on the network. Now the tokens that you had put inside the machine were actually ethers. Ethers are the cryptocurrency token of the Ethereum network and they're used to pay for the transaction fees. There's also another parameter called gas, about which we'll talk later, that is used to pay for the computational services on the Ethereum network. Now since we're still talking about transactions over here, I'm sure some of you might be wondering, why was there a need to develop Ethereum in the first place when Bitcoin blockchain already existed? So I'll give you a clear understanding on how Ethereum differs from the Bitcoin blockchain on various fronts. Now firstly, both these blockchains are conceptually different from each other. While Bitcoin's core idea was to bring a decentralized digital money that is not governed by anyone, Ethereum, although a derivative, extends beyond the realm of cryptocurrencies. That is why it is also referred to as the second generation of blockchain. Now talking about the cryptocurrency tokens, Bitcoin's crypto is named after itself and it's called Bitcoin Cash, whereas Ethereum's crypto token is called Ethers like we just discussed. Now coming to the scripting language, Ethereum is a Turing-complete scripting language, whereas Bitcoin is a simple stack-based language and it is not Turing-complete. What I mean when I say the word Turing-complete is a language that can solve any computational problem by itself, given enough time and energy. Now next we come to the consensus algorithms. Bitcoin uses the SHA-256 hash algorithm, while Ethereum's algorithm is called ETHhash. Both of these are proof of work currently. However, Ethereum will move to proof of stake in the near future as a part of its scalability plan. Now, proof of stake is still an algorithm with the same purpose as proof of work, but unlike it, where the miners are rewarded for solving the mathematical problem with the goal of validating transactions and then creating a new block, with proof of stake, the creator of the block is chosen depending on its wealth or stake. So, more the number of tokens you own, more would be your mining power. Now, even the coin release method of both the blockchains were different. While Bitcoin came through the mining of the Genesis block, so the first miner earned some Bitcoins as a reward, Ethereum's coins were released through initial coin offerings to raise funds for the new cryptocurrency. The average block creation time of both the blockchains vary, where it takes around 10 minutes for each new block to be created on a Bitcoin blockchain. In the Ethereum blockchain, a new block is formed in every 15 seconds. This is quite faster. Now, since we're talking about Ethereum, we have to discuss about the types of Ethereum accounts. As we can see here, there are two types of Ethereum accounts: the externally owned accounts that are owned by people or organizations, and the contract accounts which are autonomous in nature. Now, these externally owned accounts are controlled by private keys which are owned by individuals. But on the other hand, the contract accounts have associated contract codes, and these are triggered by the transactions or the messages received by other contracts or other externally owned accounts. Now, the contracts that we are talking about here are actually the smart contracts. Contract accounts operate on codes which are written in smart contracts. Now the users can create a new contract by deploying code to the blockchain. Now guys, smart contracts are basically immutable pieces of codes that run on the Ethereum network to perform a certain transaction or task. And when these contracts are running on the blockchain, they act like a self-operating computer program that automatically executes when specific conditions are met. Let me give you an example of this. A contract between two parties is written as a code on the blockchain. Now the individuals involved are anonymous, but the contract is public to everyone on the blockchain. So when a triggering event occurs, which in this case is a bet on an ongoing cricket match, the contract executes itself according to the terms of the code. Therefore, if England wins the match, Bob will receive 10 ethers. But if England loses the match, Andy will receive 10 ethers, and both their wallets will be updated accordingly. Now the codes in these smart contracts are written in a special contract-specific language called Solidity. A question will naturally arise over here that why was there a need to develop a contract-specific language? Why couldn't we just use the already existing languages like C, C++, Java instead? So let's see why Solidity is preferred over other languages. Now Solidity's syntax is very similar to JavaScript. It was developed because using the mainstream languages on a public blockchain won't really add value, because firstly, there are security requirements. You see, anything that gets recorded on the blockchain becomes immutable, so there is absolutely no window for bug fixes. And secondly, it costs money for executing each instruction on the program. So if you were to use C language or Serpent, for example, to write a smart contract, then you may end up with a very expensive contract and not even know why. If you guys want to create your own smart contract, then you can do that by using the Remix IDE. Now this is a browser-based IDE and it's widely used for developing the smart contracts since it has an integrated debugging and testing environment. Now here's what a Remix IDE looks like. The contract codes are written over here. This is the compile tab. Now whenever a new line of code is added to the contract, it gets compiled automatically. This is the run tab, under which we can specify the environment, the account addresses along with the associated number of ethers, the gas limit, and the value in ways. Now every time you write a code here, you can create a contract by clicking on the create button. Now guys, we'll be writing a demo contract to understand better how all of this works. But before that, let me talk about the EVM where all of these contracts are actually executed. EVM, or the Ethereum Virtual Machine, is a Turing-complete software that runs on the Ethereum network. It enables anyone to run a program regardless of the programming language, and even non-specialized programmers can create a program on the EVM. Let me tell you how all of this works. A user requests 2 ethers, for example, from the sender. Now the sender initiates the transaction message code and must pay for each step of the program that they activated, including the computations and the memory storage. Now this fee is paid in ethers, which is taken from the wallet of the sender. Then this transaction fee is collected by the nodes in the network that run the EVM. Now each and every node of the network runs the EVM to execute the same instruction, and this is how the blockchain database is maintained and updated by the many nodes connected to the network. Now all of these nodes are actually the miner nodes that execute and verify the transactions and then update the state of the accounts on the Ethereum blockchain. In turn, they're rewarded with ethers for each successful block mining. Now once the transaction is verified and recorded, the user gets 2 ethers in his wallet. Now, I'm sure some of you programmers out there might be wondering the same as what our little guy here is thinking about. That if the EVM is running the application code, then what's preventing a piece of code from running forever and overloading the network? Well, here's where the term Ethereum gas comes in. Now, gas is basically the execution fee that the sender pays for running a program on the EVM. It's called gas because the fee acts as a crypto fuel driving the execution in smart contracts. Now, every contract specifies the gas limit, which is the maximum quantity of gas that can be consumed. If you guys want, you can just go to your browser and type in the ETH gas station and click on the first link. Now here's where you can see the gas used for the current transaction. You can also see the gas price and the top 10 miners that have mined the blocks. You can see the cheapest gas price and the highest gas price, and also the confirmation time by the gas price. Now, gas price is specified at the start by the initiator of the transaction. Now, as the transaction starts, the gas used times gas price number of ethers are subtracted from the sender's account. So when a program crosses the gas limit, the execution reverts and the ethers are not refunded. So guys, it's very important to keep your program well within the set limits of the gas. Okay guys, now we come to the most interesting part of our tutorial, that is how to deploy smart contracts. So we've just learned that smart contracts must pay gas for the computations on the Ethereum network. Hence, if you rent the Ethereum network to run a contract, you'd have to pay for it. So before deploying an actual contract on the Ethereum blockchain, we need to experiment because we cannot afford to make any mistakes as anything deployed on the blockchain becomes immutable and costs gas. So we use testnets for developing demonstrated smart contracts, and these testnets simulate the Ethereum network with providing free and unlimited gas. So this allows the developers to test contracts without having to pay real money for their execution. Now I'll walk you through setting up a development environment so that you can deploy and test your own smart contracts on the Ethereum test blockchain. We're going to create a test environment on the Ubuntu Linux platform, and since I myself have the Windows operating system, I'll be using the Oracle VirtualBox to run Ubuntu. Now let's open the CLI. To run a network, we need a server. So we need to install Node.js and the Node Package Manager, since Node.js will simulate the test server on our local machine. NPM, or the Node Package Manager, is a command line interface program to manage the Node.js libraries. Now we'll run the following command on our terminal to install Node.js. Sudo apt-get install Node.js. We'll type in the password. It's asking for confirmation. Tap Y. And now we'll just wait for our Node.js to get installed. Now we'll also install the npm package. For that we'll use the same installation command, sudo apt-get install npm. Do you want to continue? Yes. And now we'll just wait for npm to get installed as well. Alright, let's just check the version of the Node.js and the npm that we have installed. So we'll type in Node.js-v. The version is 4.2.6 and npm-v. The version is 3.5.2. Now guys, this is not the latest version, so we need to upgrade our node packages since we need the upgraded versions for running the further commands. For that we need to install curl first. So we'll type the installation command, sudo apt-get install curl. Now curl is a tool that is used to transfer data from the server. Now we have installed curl, so we'll just pull the entire node package from curl, and for that we'll use the following link. Now note that the 6.x here denotes the version of the Node.js, that is 6, that we want to install. Now we'll install the latest Node.js package using the same installation command, sudo apt-get install Node.js. Do you want to continue? Of course I do. And now we'll just wait for our latest Node.js package to get installed. Now let's check the Node.js version, Node.js-v. The version is 6.13, so it's cool. Now let's upgrade our npm as well, and for that we'll use the following command, sudo npm upgrade npm-g. Now -g is used for the global installation so that we can access it throughout our system. Now we'll just wait for our NPM to get updated. So guys, our NPM has upgraded to version 5.7, which is great. Now let me just clear the screen for your convenience. Okay, now guys, we need to run the test RPC on our terminal to deploy and test our blockchain contract. Now test RPC is a Node.js based Ethereum client for testing and development. For that, we need to create a test RPC file. So we type in the following command: sudo npm install -g ganache CLI. Now note that sudo is used so that the user has an authority over the existing files. Ganache CLI only runs when our Node.js version is at least greater than 6.11, and ours is 6.13, which looks good. So now we'll just wait for it to get installed. This might take a little while. Now to install the test RPC file, we'll run the following command: sudo npm install -g ethereum.js test RPC. With this command, we'll add all the node packages on our local machine. So now we have created our test RPC file. Now let's run it and see what happens. Alright, looks great. The test RPC is running and listening on localhost 8545. Now guys, you can see the available accounts as well as the private keys over here, and we'll be using these for our contract deployment. Okay. Now we just open a new terminal because our test RPC is running on this one. Let me increase the font. Okay. Now next what we need to do is install the Block Explorer to help us keep track of the information on the blockchain. For that, we first need to install Git. Now Git is a distributed version control system that holds the repository of our Block Explorer in this case. So for that, we'll use our installation command, that is sudo apt get install git. We'll enter the password. And seems like I already have Git on my system. But anyway, you can use the same command to install Git on your systems as well. Okay. Now we need to get a copy of the Explorer on our local machine. And so we'll use the following command: git clone https github.com/etherparty/explorer. Now we can see that it's cloning into Explorer. Now it's basically pulling a clone of the repository from the cloud to our system. Okay, so it's done. Now we'll just change the directory to the Explorer by using the following command: cd explorer. Now guys, cd here stands for change directory. We'll just press enter, and now we can see that our directory has been changed to Explorer. Okay, now guys, if you want to launch the Block Explorer, you'll use the following command: sudo npm start. Now this command will install all the packages on our system. Okay, so we'll just wait for it to get installed. Now we can see the Explorer running on port 8000 over here. Alright. Now guys, if you want to view the Block Explorer, you simply need to go to your web browser. I installed Chrome because it's preferable to me. And then type in localhost 8000 on the browser tab. Now here we can see the Ether Block Explorer page has been opened, and this is where all the transactions are being recorded on the Ethereum test network. So now that we have set up our test environment, let's create a demo smart contract to deploy it on our Ethereum test blockchain. For that, go to your browser and open the Remix IDE. Now go to the Run tab and specify the environment as Web3 provider. They'll ask you if you want to connect to an Ethereum node. Click OK. Our Web3 provider endpoint is localhost 8545. Click OK again. Now guys, if this message pops up that it's not possible to connect to the Web3 provider, then all you need to do is go to your browser tab, click here and load the unsafe scripts. Now we'll go to our Run tab again and specify the environment once more. Click OK, click OK. Now we can see the associated accounts that were in our test RPC file that we created, along with the associated number of ethers as well. Okay. If you want, you can go to your file location and just open the test RPC file. Now these are all the account addresses, and this is the same as you can see over here. Okay, now we'll create a demo contract so that you guys get an idea about how a smart contract is executed. Now we'll write a contract to increase and decrease the value of the variable, let's say named counter. So we'll just open a file and let's name it my contract 001. Now these contracts are basically a collection of code functions that correspond to a specific account address on the blockchain, as you can see here. So now we'll start writing our contract. For that, we'll first specify the source code version. So we'll type in Pragma Solidity version 4.1. Now guys, note that the latest version of Solidity is 4.16, but that won't be supported by our system, so I'm using 4.1. If you want, you can use 4.16. That will not really make any difference in the program that we are writing right now. Okay. Now Pragma is the instruction for the compiler about how to treat the source code. Now since we're creating a contract, we'll use the keyword contract and let's name it as my contract. Now our entire contract would be written within this scope. Now we'll specify our state variable, that is counter, with the value 5. So we'll type in uint256 counter equal to 5. Don't forget the semicolons, guys. Now uint256 is basically the type of the variable, that is unsigned integer of 256 bits. Now this creates a slot in the database that can be accessed whenever a function in the code is called. Now also note that we need to keep the state variable outside of all the functions so that they can be accessed globally. Now we'll write a function, say add, which will increment the value of our counter by 1, counter plus plus. Okay. Similarly, we'll create another function. Let's call it subtract. And this function would be used to decrement the value of counter by 1. So we'll write counter minus minus. Okay. Now note that the access modifier in both these functions is public. Guys, although public is the default modifier when no visibility is specified, typing out the function visibility is a good habit, so you should always do it. Now there are other access modifiers like external, internal or private, but we do not need to know about them right now. What we need now is a function to output the value of the counter as it changes with the functions called. So we'll just write a function and we'll name it getCounter. The access modifier is public here as well. And since this function is going to return a constant, so we'll use in the constant keyword. Return counter. Now guys, note that we must tell our function the type of the state variable it will return. So we have specified uint256 over here, since this is the type of our counter state variable. Now whenever a function is called, a small amount of gas is spent, but no gas is required when returning a constant function. Alright? So guys, we've just finished creating our very first contract on the Remix IDE. Now let's test our first contract by clicking on the Create tab. Here you can see all the 3 functions that we have created just now. Now if you tap on Get Counter, we get the value of our counter as 5. If you tap on Add Once and then again on Get Counter, you'll see that our value of counter has incremented by 1 and has become 6 now. Now let's tap on Subtract twice and then again on Get Counter. We see that the value of our counter is 4 now. Alright. Now we'll open our Block Explorer to see the details of this transaction. Here, we'll just refresh it. And as you can see here, our contract has been successfully deployed on the Ethereum test blockchain. So now we have seen how the Ethereum is used as a platform to create smart contracts. Now guys, once you start creating your contracts and deploy and execute them on your blockchain, you will be ready to get started with creating full-on decentralized applications. Now we're not going to go into details of the dApp development, but I'll introduce you to what dApps are. Well, a decentralized application or a dApp is a set of smart contracts that operate on the data stored in those contracts. Now an application qualifies as a dApp only when it is open sourced, when it's decentralized, it has tokens fueling for itself, it generates tokens, and has an inbuilt consensus mechanism. Now these dApps enable direct interaction between the users and the providers, and they're comprised of various organizations that work together to create an application. Now these organizations are basically the decentralized autonomous organizations, or the DAOs. Now guys, a DAO is very similar to a normal company. Now the only difference is that in a normal company, there is a third party, of course, and the rules are not enforced digitally. But the DAOs have their business decisions made electronically through the codes written in the smart contracts or through the vote of their members. Now the priority of these votes depend on the percentage of the assets that the entities within a DAO hold. Let me tell you in detail how all of this happens. People add funds to the DAO and are given tokens to represent their percentage of assets. So more you invest, more number of tokens you would hold. Now when a DAO begins to operate, the members propose on how to spend the funds, and based on the votes, the proposal status is decided. This way you do not need a third party to depend on, and hence more effective operations can take place. A number of possibly disruptive dApps have already appeared in the market and are continuously being deployed on the Ethereum platform. A few of them being YFund, 4G Capital, Storge.io, and the KYC chain. Now these are a few of the most famous dApps and DAOs that are in the market currently. YFund is a dApp that uses the smart contracts to enhance crowdfunding services like GoFundMe and Kickstarter. 4G Capital is a DAO that provides microloans for small businesses in Africa. Storge.io provides censorship-free, secure cloud storage by sharing data among a decentralized network of computers. And last but not the least, the KYC chain allows the users to maintain a private identity wallet that can be used to authenticate the identification in finance and commerce settings. Guys, with this we come towards the end of our session, so let's summarize what all we have learned in this tutorial. Now we know what Ethereum is and about the types of Ethereum accounts. We learned about the smart contracts and the EVM. We also performed a practical demo on how to deploy the smart contracts. And towards the end, we talked about the future of Ethereum. Now, if you guys have any queries or if there is anything more you want to learn about Ethereum, feel free to write down in our comment section below. With this, I take your leave. Thank you and goodbye.
Bitcoin and Ethereum are the two biggest giants of the cryptocurrency world. Bitcoin was the first coin and Ethereum followed a few years later. So hello all, here I am Atul from Edureka, and today we are here to compare these two popular platforms. So without delaying any further, let's discuss the agenda of today's session. So here what we're going to learn today. I'll be comparing the Bitcoin and Ethereum based on these 6 parameters, starting with cryptocurrency, then accounts, then we'll see how both the coins differ on the basis of their smart contracts. Following it will be the transaction, the fifth will be the consensus, and finally we'll see how both the coins differ on the basis of mining. Alright, so let's start now. When everyone has access to global market, great idea flourish. That's the ideology of both these platforms, which is why both are open source digital currencies. Now, what makes Ethereum and Bitcoin similar? Just like Bitcoins, Ethereum also has a digital currency which is named as Ether. And both these valuable cryptocurrencies uses the proof of work mining. Alright. Now, even though both are blockchain implementation, they serve different purpose. And that is why there are stark, obvious difference between the two of them. Alright, before we undertake an analysis of these two cryptocurrencies and platform, let me give you a quick introduction of Bitcoin and Ethereum. So let's talk about Bitcoins first. So what is Bitcoin? Bitcoin can be quickly described as a digital money.
It is a decentralized global currency issued by a code stored across the globe. The quick introduction for Bitcoin regarding the coding aspect is that everyone can download a computer program which stores all transactions in a chain of blocks called blockchain, obviously, and through which it can validate that you are the owner of the Bitcoin while ensuring that you can spend it only once. All right, fine. Moving on ahead. So what is Ethereum? Ethereum is a world computer for developing decentralized application. Just like Bitcoins, all the parameters applies for Ethereum too. But on top of that, Ethereum also has a smart contract making the currency aspect as just one application. Because Ethereum can run programs like any ordinary computer at a global scale, right? So just like Bitcoin, it has a software which you can download. The software does all the usual verification regarding Ethereum. But on top of it, it also verifies the code wherever applicable. Fine. So to churn it down, Ethereum can be defined as a decentralized platform for programming a digital money. Okay, so this was a brief introduction of Ethereum and Bitcoin. So let's start with our first comparison. So the first parameter being the cryptocurrency. Now, if you compare the coins based on purpose they were developed, you will see that Bitcoins was created after the 2008 financial crisis with a vision to remove the dependencies on third parties to facilitate the transaction and hence disintermediation. Ethereum, on the other hand, serves two main purposes. Firstly, it is a cryptocurrency that is used to run the state machine of Ethereum. So you see, Ether is a fuel that is used to pay for every single computational step. The invention of Ethereum makes it expensive to use up to too much of blockchain computer's capacity. Ether is the fuel you need to run smart contracts. If considering an analogy, if Bitcoin was a digital gold, then Ether is a digital oil. Fine. Secondly, apart from that, Ether is also traded on exchange just like any other cryptocurrencies out there in the market. Fine. So next we'll compare the two based on the accounts. So let's see in the case of Bitcoin what we do in the case of accounts. Bitcoins does not have a distinct account, but it maintains the ledger of unspent transaction output, or simply said, it maintains the state of where the coins are flowing. On the other hand, Ethereum maintains proper accounts. Accounts play a central role in Ethereum. There are basically two types of accounts in Ethereum. First being the externally owned account, the EOAs, and the second being the contract accounts. Accounts have balance, and contracts have both balance and contract storage. The state of all account is the state of the Ethereum network, which is updated with every block and which the network really needs to reach a consensus about. Accounts are essential for users to interact with Ethereum blockchain via transactions. Accounts represent identities of external agents, example, human personas, mining nodes, and automated agents. Accounts use public key cryptography to sign transactions so that the EVM can securely validate the identity of the transaction sender. Externally owned account maintain the state of the balance and has ether balance, can send transaction and is controlled by private keys. Fine. Next is the contract account. It maintains the state of balance and storage. It also has ether and the associated code. The code execution is triggered by transactions or messages received from other contracts. Now, since we are at the smart contract, let's differentiate the two coins on the basis of smart contract functionality. So a third parameter of comparison is smart contract. While Bitcoin has a built-in scripting language, it's very limited in functionality and with only a few dozen operations. Now, Ethereum has a full general purpose language integrated in it, known in computer speak as Turing complete. Programs written in this language are known as smart contracts. Now, you would ask, what is smart contract? Now, these smart contracts are pre-written logic stored and replicated on a blockchain, which is executed by a network of computers and can result in blockchain updates. So guys, you can see that Ethereum takes a distinctive lead when it comes to programming on a platform. It has the potential to help notoriously difficult industries. So imagine the case of investment, where your selling and buying of stock is done for you by the code itself. Also in the case of insurance, where you can automatically trigger the claim whenever the event occurs. Another important application of smart contract could be in the supply chain management. And even the fundraising part. Yeah, the fundraising could be made easier with smart contracts. Rather than being limited to a specific set of transaction types, user will be able to use Ethereum as a sort of Lego of crypto finance. That is to say, one will be able to implement any feature that one desires simply by coding it in Ethereum's language. That is why people believe that Ethereum is potentially more lucrative than Bitcoins. Fine. Now let's move ahead and compare Bitcoin and Ethereum on the basis of transaction as a key attribute. So transaction throughput in Bitcoin is close to around 3 transactions per second, which is almost 5 times lesser than in Ethereum. So Ethereum takes a huge lead in case of transaction processing speed. Let's have a closer look at the calculations here. Talking about the Bitcoins first, the maximum block size by average transaction size will give you the average transaction per block. which is close to around 2000 transactions per block. Unlike in Bitcoin, there is no fixed megabyte limit for the size of the block. In Ethereum, a block size is limited by a total gas consumption limit. For instance, in April 2016, the total gas limit amounted to around 4712,388 gas, which can be spent on every block. So the average transaction per block can be calculated as average gas limit defined for a block divided by average gas for a transaction, which is 225 transactions per block approximately. Now, don't you think that's way too much of a difference, because both of these platforms follows almost the same technology? If you noticed, I said that technology is just similar. Where it differs is the way they have implemented consensus algorithm. Fine. Talking about consensus, you see the Bitcoin's proof of work algorithm has some limitation. The network is vast and growing, and hence a transaction takes considerable amount of time to propagate in a network, which causes the ambiguity in the network of Bitcoin. Also, another limitation of Bitcoin is that since the miners are the stakeholders of the network, the top mining pools control the 75% of all the mining activity, which causes the centralization in the system. Now, to tackle this problem, Ethereum has adopted the Ghost protocol that brings some efficiency gains to the proof of work. Now, Ghost solves the first issue of network security loss by including stale blocks in the calculation of which is the longest chain. That is to say, not just the parent and further ancestor of the block, but also the stale descendants of the block's ancestor. In Ethereum jargon, uncles are added to the calculation of which block has the largest total proof of work backing it. To solve the second issue of centralization, Ethereum implements a simplified version of Ghost, which only goes down one level. Specifically, a stale block can only be included as an uncle by the direct child of one of its direct siblings, or not by any block with a more distant relation. So Ethereum's modified proof of work implementation does adds to the efficiency of Ethereum's network. Positively, Ghost protocol also alters the process of mining in Ethereum. Let's see how mining differs in Bitcoin and Ethereum. The mining in Bitcoin has evolved a lot. In beginning, the CPUs were used for mining of Bitcoin. But as the computational power of the network increased, the GPUs took over the CPUs, and eventually now the ASIC miners are used to mine the Bitcoins. While in case of Ethereum, the Ethereum is ASIC resistant. ASIC should not have any benefit at all because it's just general computation. And to top it off, contracts can be released that are specifically ASIC hard, so there would be an active disincentive to using ASICs. Another interesting thing that doesn't seem pointed out in the white paper is that the memory must be fast, excessively fast. So standard DRAM isn't up to the challenge. That is why the RAM on GPUs take the brunt of the work in most mining today. Ethereum is an advancement based on the principle of blockchain that supports Bitcoin, but with a purpose that do not compete with Bitcoin. So which one do you think is better? Is it Ethereum or Bitcoin? Well, that's for you to decide. And also it depends on how you're using it or what is the purpose of your use. Alright, now if you ask a developer's opinion, now I'd say that Ethereum has its obvious advantage. So both Bitcoin and Ethereum are different versions of using the blockchain technology and are set to establish themselves driven by different intentions. Now, just like Bitcoin, Ethereum, Ripple, there are many new impactful cryptocurrencies and tokens which are arriving in the market every day. So thank you folks, this was all for the session. In case you have any doubts, add your query to the comment section. Thank you.
So if you're a developer new to Ethereum or blockchain in general, it is possible you're overwhelmed trying to understand all the tools and technologies in the Ethereum ecosystem. At least I was when I was trying to understand all this. So hey guys, this is Arya from Edureka, and for today's session I decided to briefly describe the various components you come across frequently while starting to learn Ethereum. To be more specific, let me show you all what you're going to learn in today's video. We'll discuss the jobs and salary trends in Ethereum's ecosystem. Then I'll briefly talk about some of the popular decentralized applications. Then eventually, I'll discuss the various tools and technologies for development on Ethereum's platform. Hopefully, this will help you get a bigger picture of Ethereum's ecosystem and how all the pieces fit together. All right, let's start with a brief discussion on Ethereum. Ethereum is a smart contract-based blockchain on which you can build decentralized applications that run on smart contracts. Now, if you're a technologist, you can always read the Ethereum white paper. Let me just give you guys a quick peek into it. So this is the Ethereum white paper, and you can find all the technicalities and specifications and the workings as to how Ethereum works to the tiniest details out here. If you want, you can just go ahead and check it out. So because of its huge number of applications, Ethereum is a titan in the blockchain industry. Its market value is predicted to reach soaring heights in the next couple of years. Now, having said that, the number of blockchain jobs has seen a dramatic increase according to the data provided by IT Jobs Watch UK. The amount of capital flowing into the space, mostly through ICOs, has put blockchain and smart contract developers on a pedestal. The companies are increasingly seeking experts to focus on this new technology, and job seekers have become quick to react. The amount of money and excitement in the space is driving up the demand for Ethereum developers. Because of this, they can demand very high salaries. The salary trends of Ethereum developers, specifically in the US and UK, has seen a tremendous rise in the recent years. If you look at the graph, the average salary in UK, it is seen around 100,000 euros. In high-tech regions of US such as Silicon Valley, New York, and Boston, the average annual wage of blockchain developers is around $158,000, and software developers get around $140,000. The blockchain world is quite nascent as of now, and this is the time to seize the opportunity before it fades away. Now, to become an Ethereum developer is no easy task. There are lots of tools and technologies used for the development on Ethereum, and because the platform is still evolving at a rapid pace, many such tools are getting outdated. Recently, while developing a decentralized application using Web3.js, I got a message in the Chrome console saying that Web3 will be deprecated in the near future in the favor of Ethereum provider. So it is necessary to keep yourself updated with the technology and the related tools. So first things first, to develop any application, we need a programming language. Similarly, to develop a decentralized application, we need to first create a smart contract. Ethereum gives you multiple options for writing and deploying smart contracts. The most basic to start with is Remix. It is a web interface that helps you write, deploy, and interact with your smart contracts. Another easy way to use is the integrated development environment called Pragma. So let me just show you guys Pragma for a bit. Okay, so Pragma is a tool really similar to the Remix IDE, and that lets you write, deploy, and interact with your contracts directly from your browser. It is more limited than Remix, but easy to understand and use. After deploying your contracts, you can even share a user interface that lets your users interact with the smart contracts in a really simple way. This is one of the key features, as users don't need to install anything aside from MetaMask, and you don't have to develop any front end. Pragma is the #1 go-to tool for the first-time Ethereum developers that just want to play around and test the features of Solidity. You can also use code editors for writing and editing Solidity code files like Visual Studio Code, which is a source code editor developed by Microsoft. Another cool editor would be Atom, which is easily available for Mac OS, Linux, and Windows. So now that we are done discussing the text editors that you might need to develop Solidity code, it's time we look at the compiler that is used for compiling Solidity. So Solidity, while it looks like JavaScript, you still need a different compiler to compile it. So the compiler that we used is called SOLC. So let me just show you the documentation for it once. So in the documentation, you can find how Solidity compiler actually works, and you can find all the installation guides that are used for actually installing it. In my opinion, you can just easily install it through Node.js or Docker. The Solidity compiler is your translator from the smart contract language to Solidity Ethereum's bytecode. So what happens is the contract definition is passed through the compiler, which generates a bytecode and the application binary interface for deployment on Ethereum blockchain. Okay, so now suppose you've written a Solidity code and it turned out to be faulty or has security issues. Since you pay by size for all you write to the blockchain, contracts included, it's in your interest to make sure you're not wasting your money by uploading faulty code. So we have a tool for this, and that is called Solium. Solium identifies and fixes style and security issues in your Ethereum smart contract. Its redistributable configuration files provide great flexibility in which checks to apply. You can automate, extend, and integrate all using Solium. You can extend Solium functionality by writing your own plugins or use the best ones distributed and maintained by the community. You can integrate Solium with your CI system like Travis and Jenkins. This empowers you to standardize coding practices between your organizations, making review and audit a breeze. All right, so far you have written a nice contract and compile it using the Solidity compiler. Now you have to set up a development environment to deploy your contracts on Ethereum blockchain. To interact with Ethereum blockchain, we have tools called Ethereum clients. People who are new to Ethereum mostly go with Get client, but I mostly prefer Parity. Parity is the fastest and most secure way of interacting with Ethereum's blockchain. Formed by Dr. Gavin Wood, the former CTO of Ethereum, this client is fast, lightweight way to run an Ethereum node. Run Parity and hop over to localhost 8080 to play around in their web UI. Honestly, it's a cumbersome process to install, but once it's up and running, Parity is a big upgrade from Get. If you want a simple access to the blockchain through the browser, MetaMask is a very beautiful option. This little Chrome extension drastically improves how easily people can interact with your decentralized applications. It is unrealistic for everyone in the world to run a node to interact with the blockchain. So if you want a simple access to the blockchain through the browser, MetaMask is an option. This little Chrome extension drastically improves how easily people can interact with their decentralized application. It is unrealistic for everyone in the world to run a node to interact with the blockchain. So the folks at MetaMask host several nodes so that you don't have to. All you must do is install MetaMask and it automatically connects to their nodes. So MetaMask allows you to run Ethereum decentralized applications right in your browser without running a full Ethereum node. It is a plugin for Chrome and uses services called Infura. Infura has Geth or parity blockchain nodes installed. There is another important application of MetaMask. When dealing with your transactions on the mainnet, you need to check for security. Wallets are not secure anymore, and the best way to use MyEther wallet is to use it with MetaMask to carry out your transactions securely. So now let's discuss about MyEther wallet. So let's visit MyEther wallet first of all. So MyEther wallet is a free open source client-side interface for generating Ethereum wallets and more. Using MyEther wallet, you can interact with the Ethereum blockchain easily and securely. You should always double check the URL before unlocking your wallet. Now let's discuss some of the command line tools that are available for development of Ethereum applications. So there are some command line tools that make development a lot easier. These are Truffle, Embark, and dApp. Until now, the only way we used to interact with our contracts was to deploy them manually through a node console into a local Ganache node and then load them using Web3. Now we have Truffle. Truffle is a development environment, testing framework, and asset pipeline for Ethereum, aiming to make life as an Ethereum developer easier. Truffle provides the building blocks to quickly create, compile, deploy, and test blockchain apps. Although Truffle is considered as the most suitable framework, it seems we have a second choice here too, and that is Embark. Embark is another popular framework for building, testing, and deploying your apps. With Embark, you can automatically deploy your contracts and access them with the JavaScript promises. Embark monitors the changes and will redeploy your contracts on the decentralized applications when updated. It manages chains and keeps tracks of all deployed contracts very easily. Then we have dApp. It is a simple command line tool for smart contract deployment. The documentation contains all the information you need to get started with for using dApp. These were some really smart frameworks which makes the building of dApps much easier. Now, wouldn't it be cool if we had the infrastructure to ensure that your decentralized application scales to meet the demands of your users? So for this, we have another tool called Infura. So let's visit Infura's site for once. So as you can see, according to Infura's website, they provide scalable and safe Ethereum nodes that become available for developers. When starting with blockchain development, something can be a deal breaker is getting the blockchain on your device. Thanks to Infura, you can access any data you would normally access through Web3.js tool through their API. Infura provides to anyone, free of charge, a set of nodes you can query to get blockchain informations, transaction receipts, and events. On their website, they tell that they handle more than 5 billion requests per day and more than 9,000 developers. To use Infura, you need an API key that you can get by registering on their website. You should note that some operations are not permitted as they may be too costly for them to handle, such as new blocks and event listening. Next on our list of tools, we have Dapboard. So Dapboard is analytics platform for Ethereum smart contracts. Dapboard is a new Ethereum blockchain explorer. With this tool, you can easily see in a visual way how smart contracts and decentralized applications are doing, how many users are using a decentralized application, how much Ether is processed by the contract, and much more. You can also visualize global charts that compare games and tokens living on the blockchain. Alright, these were some really cool technologies and tools for Ethereum development. Now let's see how these tools fit together to constitute the Ethereum ecosystem. As you can see from the infographic, the Ethereum network consists of multiple nodes, and one of the nodes holds your deployed smart contract. Now, to interact with the nodes, we either use Geth or parity, and we use MetaMask or Mist to actually deploy and interact with our contracts. Then there is ENS, which is Ethereum's naming system, which is a DNS for the Ethereum world. Just like you map an IP address to a human readable name, you can map any Ethereum contract or wallet address to a human readable name. Then we have Swarm and IPFS. Swarm is a decentralized content storage and distribution service. You can think of it as CDN, but instead of the entire CDN being hosted on one company's server, it is distributed on computers across the internet. Just like you run an Ethereum node, you run a Swarm node to connect to the Swarm network. IPFS is conceptually exactly similar to Swarm. It is a decentralized storage system, and it is not related to Ethereum directly, but can be integrated with Ethereum very easily. So that's it from me, guys. I hope you all learned something new about Ethereum today. Goodbye. Hi guys, my name is Arya and I'm from Edureka. Welcome to this session on smart contract tutorials. So we'll be going over the following topics today. We're going to discuss what a smart contract is, we're going to see who invented smart contracts, and we're going to discuss their key properties. We're going to go through the development languages and the advantages and disadvantages of smart contracts. Furthermore, we're going to see through some smart contract tools that are really necessary for development, and in the end of this tutorial, I'm going to show you all how to deploy your own smart contract on a test network. So without much ado, let's get into today's session. When blockchain was released back in 2009, people didn't know what to really use it for, other than the general bookkeeping of transactions. Well, it's been almost a decade since blockchain was invented, and we've come across really interesting use cases that implement the blockchain in their own unique ways. One such use case is Ethereum, which was the first blockchain platform that implemented the concept of smart contracts. So what exactly is a smart contract? Well, a proper definition states that a smart contract are executable logic that runs on a blockchain network. This basically means that smart contracts are just simple programs that run on the blockchain. This opens up the blockchain to be used in a variety of sectors. Smart contracts are available that control the logic behind simple things like gambling, asset transfer, vote counting, etc. Blockchain is also the ideal space for smart contract storing due to its decentralized nature. This allows smart contract to realize transactions without the need of an intermediary. Even though the first application of the concepts of a smart contract was with the launch of Ethereum, the genesis of the idea dates back to early 1994, and the entire credit goes to Nick Schwabu. Nick was well known as a cryptographer and a computer scientist. He introduced his idea of electronic contracts that would handle protocols regarding e-commerce when strangers met on the internet. In 1998, Nick even designed a mechanism for a decentralized digital currency called Bitgold. Even though it was never implemented, it acts as a direct precursor to the Bitcoin architecture. Today, we have numerous blockchain platforms other than Ethereum that support smart contract functionality. For example, Hyperledger Fabric, NEM, and Stellar. Regardless of the platform they are deployed in, smart contracts have some general key properties. Firstly, every smart contract is autonomous in nature. This means that once a developer has created his logic and deployed it on the blockchain as a smart contract, he does not need to participate in any of its processes. Smart contracts are also auto-sufficient, which means that they can collect money, realize transactions, distribute resources, issue and spend to allow a larger capacity of storage and computation power. Lastly, smart contracts are decentralized. They are distributed by various network points instead of being focused on one single central source. Smart contracts are mostly developed in their network-specific languages, like Solidity, Serpent, Viper, but there are application programming interfaces these days that allow developers to develop their smart contract in languages they are familiar with, for example, Python and JavaScript. Smart contracts come with their advantages and disadvantages. Let's discuss their advantages first. First of all, smart contracts assure complete safety and security as data in a decentralized registry cannot be lost or hacked. Secondly, they remove third parties and hence assure agent neutrality in signing of deals. Next, as smart contracts are completely automated, this means that it performs the job with utmost precision without a chance for human error. And since everything is automated and run by code, it also saves a lot of precious time. Like every technology, smart contracts too have their own shortcomings. Firstly, they are a hassle to maintain. As things are immutable on a blockchain, this means that every time you update your smart contract, you have to deploy it as a completely new contract at a new address. The concept of a distributed and decentralized backend service is difficult to understand for inexperienced developers. Since it is a new technology, people generally tend to be suspicious and skeptic when implementing smart contracts. Now that we've seen the pros and cons, let's see the tools available for helping us build our smart contracts. Every contract firstly needs a wallet to store its transaction values in. There are many wallets available like Mist, Armory, and Multibit which serve this purpose. Secondly, we need a framework which makes our lives as a developer much easier for deploying these contracts. Good examples of frameworks include Hyperledger Fabric and Truffle. We also need a compiler for our scripting language, but these can be easily replaced by online compilers like Remix and Composer Playground. Lastly, we need a test network to actually test our smart contracts on, as once they are deployed on a regular blockchain network, they become immutable. Smart contracts have seen some really interesting use cases over time. Let's go through a few of them. Gambling, for one, has been made secure and lightning fast with the use of smart contracts. Voting smart contracts exist that make the process completely transparent and corruption-free. Smart contracts are also being used to speed up processes involving deal signing, for example, financial agreements and insurance policies. Other than that, smart contracts are also being used to automate entire organizations where things like payment distribution, incentive handling are completely automated. These organizations are commonly known as decentralized automated organizations. Now that we've seen everything about smart contracts, it's time we deploy our own smart contract on our test network. For this exercise, we're going to need Node.js and npm installed and updated to the latest version. For the following exercise, we'll be using the following technologies. We'll be using Web3.js framework to interact with our smart contract through a front-end API. We'll be using TestRPC as our test network, and we'll be using Solidity to develop our contracts, and compiling them will be done through the Remix browser. So without much ado, let's get started. To get started, we must go to the Remix browser first. As you can see, you get a smart contract out here. So we'll be creating our own smart contract. So press the sign button and give it any name you want. So we'll be compiling our smart contract through this Remix browser, and we'll be developing it in Solidity. This contract will not be very complicated, as the motive of this exercise is to show how you can deploy your own smart contracts and test them on a test network. So let's get started. We define our contract with the contract keyword, and we'll call it demo. Now we need one variable, and it's going to be a string, and it's going to be public, and it's going to be called name. We're going to make two functions, one to set the name, so function set name, which takes an argument string and sets that string to the name variable. Next, we need a function that gets the name, so function get name, and this is going to be view only and a public nature, and it will return a string. So it's going to return the variable name. Now that we've created our smart contract, it's time to compile it. So you just go and press start compile, and as you see, we only have warnings which we don't really care about, and we don't have any errors in the smart contract. So next, we will need to set up our test network. For that, open command prompt and go npm i-g ganache CLI. Now you just wait for it to install. Now that it's installed, just type in the command ganache CLI, and this should start up your test network. So as you see, that our test network is up and running, and this gives us 10 accounts. These are the public keys, and these are the private keys. So on the Remix browser, go to the Run tab and change the environment to Web3 provider. Click OK. And as you see, the provider has been changed to the Web3 provider, which is running on the test RPC. So now we need to create our contract, and it's been created at this address. Now it's time that we create our front end for this contract. So to do that, you open command prompt again, go to desktop, okay, and you make a folder. So we're going to call our folder test, and you go into that folder and you go npm init. Just press enter through all these questions and you're done. So we've basically initialized our JSON files. So now we need to also install our framework. So for that, we go npm install -- save, so that it gets saved as a dependency in the JSON file, and Ethereum JS Ethereum /web3.js. Oh, I made a spelling mistake. This won't get installed properly. npm install Ethereum /web3.js. Once the framework is installed, just go and check in the folder. You should have 3 folders, one with node modules, and you should have this web3 folder out here. So now we'll have to create our front end. So for that, we're going to create a new file. So go to the folder where you installed web3.js in and initialize your project and create a new text file. We'll call this index. It shouldn't be a text file. So we're going to save this as in the same folder. We've got an index.html. So now we just put in the HTML boilerplate, and we're going to call our web page Smart Contract Tutorial. Second of all, we need to include our script. So the source is, go to the node modules, you go to web3, you go to dist, and you just copy this thing. And don't forget to change these. And the end, type web3.js. Now we've done that, we will create our HTML for this particular thing. So it's going to be very simple. We have a div, and in this div we're going to have an input. So input type will be text, and we have given name, we'll give it a placeholder. We enter name, and now we're going to have a button. So button, and we're going to call it set name. Let's give this, and we're going to have an output part, and this is just empty. So let's give these some IDs. So let's give this an ID of input. This will have an ID of button, and now this will have an ID of output. So let's see what this looks like. Yeah, so we have our basic thing. So if I type in my name and set name, something should come out here. So let's get that working. For that, we need our script. And so let's declare a variable called web3. We're going to be using this variable to reference our framework. So if type of web3 is unequals to undefined, I'm going to set the network provider to web3 equals new current provider. So if it's an undefined type, we set to the current provider, and else web3 equals new web3 dot providers dot http provider. It's gonna be, what was our CMD running at? It was running at localhost 8545 if I'm not wrong. So http. So now that we've specified our provider, we need to specify our default account. So web3.ed.default account .ed.accounts. This basically means that we're setting the first account as the default account, and we'll be doing all our transactions based on this. So now we need to define a contract. So our new contract equals to web3.eth. Now we need to paste in our contracts ABI out here. The ABI stands for Application Binary Interface. To get the application binary interface, go to the compile tab, go on details, and you basically need to just copy this small thing out here. Wait, yeah, this thing ABI. Copy this and just paste it out here. This basically shows what functions are there in the contract. Next, we need to instantiate our contract. So var contract equals to new contract dot add. So dot add, we specify the address of our contract, which was basically this. So that's the address that our contract has been deployed at on a test network. Now we need to do some fiddling. So let's get our outputs and inputs. Var and we need to just Control-C. We'll give them a different name. This was the input, and it had an ID of input. And this was the output. This had an ID of button, and we're going to call it button. Okay, so now we go contract dot. What was the name of our contracts function? It was set name. So contract dot set name will give us, should be input dot value, and this should only happen when we click on our button. So we're listening for a click, and our callback function will basically do this. So we selected all the elements of our contract, of our HTML rather, and then whenever somebody clicks the button and sets the name, we're going to get an output from the contract get name. So let's save this now. File save, and let's try running it. Looks like we made an error. HTML 83. Oh yeah, I forgot this. That should have fixed it. Cannot read property providers of undefined. HTML 27. I forgot the new keyword out here. And okay, so document.getElement 79. Okay, this needs to be small. That was a mistake. Yeah, seems like we've run out of errors to solve now. So basically this should go, yep, now you see, we've deployed a contract on the smart contract, and now we're getting the output out here. So basically what happens is our contract is running at this address out here, right here. It knows what's in the contract through this application binary interface, which we see right here. And basically Web3.js just lets us interact with our contracts. And this is all from me. Goodbye. While all blockchains can process code, most are severely limited. Ethereum, on the other hand, is very different. Rather than giving a limited set of operations, Ethereum allows developers to create decentralized applications. Hi guys, this is Arya from Edureka, and today's video is all about building decentralized applications using Solidity language on Ethereum's platform. This tutorial is meant to provide insights into the building of decentralized apps on Ethereum's platform. Just to be more specific, let me show you guys what you're going to learn in today's video. So, we'll start our class with a short introduction to decentralized applications. Then we're going to talk about the building blocks of decentralized applications at a very macro level. Next, we'll discuss the various tools and technology stacks for building a decentralized app. Drilling down further, I'll tell you guys about the major decentralized application building tools. Lastly, I have a pretty interesting demo to show you guys, which is a property transfer use case using Ethereum. I hope that gets your attention. Alright, now let's go back to the days when Ethereum was not developed, and Bitcoin was the only ruling decentralized application running on a blockchain. So before the creation of Ethereum, blockchain applications were designed to do a very limited set of operations. Bitcoin and other cryptocurrencies, for example, were developed exclusively to operate as a peer-to-peer digital currency. Now developers faced a problem. Either they had to expand on the set of functions offered by Bitcoin and other type of applications, which is a very complicated and time-consuming task, or they had to develop a new blockchain application and an entirely new platform as well. Recognizing this predicament, Ethereum's creator, Vitalik Buterin, developed a new approach. He devised a platform that gives endless opportunities to develop blockchain-based applications by writing basic building blocks of programs called smart contracts. Now let's talk about Ethereum. So Ethereum's core innovation, the Ethereum virtual machine, is a Turing-complete software that runs on Ethereum's network. It enables anyone to run any program, regardless of the programming language, given enough time and memory. The Ethereum virtual machine makes the process of creating a blockchain application much easier and efficient than ever before. Instead of having to build an entirely original blockchain for each new application, Ethereum enables the development of potentially thousands of different applications all on a single platform. Now let's see the differences between a traditional web app and a decentralized web application. So on the traditional server architectures, every application has to set up its own server that runs their own code in isolated silos, making sharing of data very hard. If a single app is compromised or goes offline, many users and other applications are affected also. Decentralized applications, on the other hand, run on a blockchain. Anyone can set up a node that replicates the necessary data for all the nodes to reach an agreement and can be compensated by users and app developers both. This allows user data to remain private and apps to be decentralized like the internet was supposed to actually work. So what exactly is a decentralized application? Decentralized application is a program which is run by many people, which either uses or creates a decentralized network for some specific purpose. Example, connecting buyers and sellers in some marketplace, sharing files, online file storage, or maintaining a currency. Ethereum-based decentralized applications are called dApps, which stands for Decentralized Applications. Ethereum-based decentralized applications typically consist of an HTML or JavaScript web page. And if viewed inside the Ether browser, the browser recognizes special JavaScript APIs for sending transactions to the blockchain and reading data from it too. In summary, a dApp is essentially a glorified web application which can tap into the Ethereum network and the blockchain also. To point it out, dApps can have the following few characteristics. Firstly, they run on a blockchain. Secondly, their code is made open source and operates autonomously without any person or group controlling most tokens. Thirdly, they generate decentralized application tokens to provide value to their contributing nodes. And lastly, users are granted access to them in exchange for tokens. Okay, so now let's discuss the building blocks of a decentralized application. On a macro level, decentralized application is built using three major components, namely the Ethereum network, smart contracts, and the web frontend. So basically, a smart contract is written in Solidity or any other equivalent language which can be compiled to Ethereum's bytecode, which is called EVM bytecode. Such a smart contract is what allows a decentralized application to connect to a blockchain. A dApp is similar to the traditional web application that uses HTML, CSS, and JavaScript to render a page. But instead of using an API to connect to a database, the smart contract is the bridge that connects to the blockchain. Now, as you guys can see, the image does illustrate that smart contracts are playing the role of the API connector to the blockchain. Like building a normal web or mobile application, creating a decentralized application commonly requires a few things: computation, file storage, external data, monetization, and payments being the few. The community has made a lot of progress building ecosystems in the past 4 years. While it was borderline impossible to build a decentralized application in 2014, in 2018, it's feasible to build a basic dApp that requires minimal computation and file storage. The Web3 ecosystem has come a long way to develop technology stack that developers can build upon. There are two pillars to a Web3 project setup. Firstly, the Web3.js file, and secondly, the test RPC, which is the local Ethereum blockchain. Now, Web3.js is the most advanced Ethereum JS library out there, and test RPC is currently the simplest way to get a local node running. Now, here is a listing of technologies in a Web3 stack. The components in a development stack is integrated in such a way as it provides an environment to develop and deploy a decentralized application in Ethereum's network. Okay, so let's drill down to a micro level when I'll discuss some of the major tools used for developing Ethereum-based decentralized applications. So first things first, to develop any application, we need a programming language. Similar to develop a decentralized application, we need to first create a smart contract. So the programming languages that are used for smart contracts are, as you can see, are Solidity, Serpent, and LLL. Solidity is a contract-oriented high-level language with syntax that is similar to that of JavaScript, and it is designed to target the Ethereum virtual machine. Serpent is a high-level language that is designed for writing Ethereum contracts also. It is very similar to Python, but as of September 2017, Solidity is the preferred language of development for Ethereum developers. There is also another language called LLL. It is a simple and minimalistic language, and it is based on Lisp. And as you guys can guess, it also stands for Lisp-like language. Okay, so out of these three, the most popular language is Solidity. The world uses it for writing smart contracts on Ethereum, so let's talk about it a bit more. So Ethereum Solidity is a contract-oriented high-level language with syntax very similar to JavaScript. Solidity is a tool that is used to generate a machine-level code to execute on EVM. The Solidity compiler takes the high-level code and breaks it down into simpler instructions. The encapsulated code is called a smart contract. Now, to start coding a new language, you want the easiest development environment that will help you through the bugs so you can learn from your mistakes as quickly as you go. Remix should be your go-to option for writing a contract. We also have various editors for Solidity code programming, like Visual Studio Code, which is a source code editor developed by Microsoft. Another popular editor is Atom, which is a free open source text and source code editor for macOS, Linux, and Windows. But I think Remix is the most user-friendly, and let me show you guys why. Okay, so let's head over to Remix first. Yeah, so as you guys can see on Remix's site, it has a lot of features and functionality. You can write your code on this editor out here, and it'll start compiling and show you compilation errors right out here. Next, you have the Run tab, and you can run on various environments like the JavaScript VM, the injected Web3 provider, or a normal Web3 provider. Above that, you have an Analysis tab that lets you analyze your code, and then you also have a debugger, which you can actually use for debugging your code by block number or transaction indexes. Okay, so coming back to the video now, we have talked about the programming languages and the IDEs, or the browsers and editors for writing Ethereum code. Now, suppose you have written a code, or let's say a contract, you want to deploy the contract onto your blockchain. This is where clients are used. An Ethereum client is just a term. It refers to any node that is able to parse and verify the blockchain, its smart contracts, and everything related. It allows you or provides you with the interface to create transactions and mine blocks, which is the key for any blockchain interaction. The client implements Ethereum's protocols. These clients will replicate all blocks from the network to a local system until and unless they're in light client mode. These clients mines Ethereum's blocks and manages Ethereum accounts. Also, they send and receive Ether, which is Ethereum's network-specific cryptocurrency. There are also various clients supporting Ethereum's network. We have Get, which is written in Go language given by Ethereum's foundation. Then we have Parity, written in the Rust language provided by the company called Ethcore, and we also have clients written in Python, Java, and JavaScript languages as well. Out of all those many popular implementations nowadays, Go Ethereum or Get is the most popular. Get is an official Golang implementation of Ethereum's protocols. It is written in Go, fully open source, and licensed under the GNU LGPL version 3. Go Ethereum is available either as a standalone client called Get that you can install on pretty much any operating system, or as a library that you can embed in your Go, Android, or iOS projects. Now we have browsers for connecting to the blockchain. Two of the most popular browsers are MetaMask and Mist browser. So MetaMask allows you to run Ethereum decentralized applications right in your browser without running a full Ethereum node. It is an extension that is available for Chrome, Opera, and Firefox and uses a service called Infura. Infura has Get or Parity blockchains nodes running already all the time. We also have a browser called Mist. Mist is a full browser and it has its own blockchain node implemented. Mist is integrated with Get node. So basically you can store Ether, send transactions, deploy contracts, and more with Mist. You can use a native application to play around on the blockchain or a testnet while you get the hang of this whole blockchain. Super useful for quick transactions. But I mostly prefer MetaMask for connecting to the blockchain, so let me tell you guys a little more about this. So let's head over to MetaMask on the Chrome Web Store. So as you guys can see, MetaMask is available as an extension for Chrome. What it does is it injects the current Web3 API into the Chrome browser so that you can actually read data from the blockchain and send transactions to it in a very secure and seamless manner. Okay, so coming back to our video, let's talk about the frameworks. So the only framework that is available for development purposes on Ethereum is Web3.js. Just like you have Get, Mist browser, or so on to communicate with Ethereum node, there is also this library called Web3.js, which can be used to interact with the node. Since it is a JavaScript library, you can use it to build web-based decentralized applications. So who'd like an application without an interface, right? If you want to build a decentralized application, you're going to get very personal with Web3.js library. Web3.js is going to be the interface you'll use to interact with the blockchain if you're trying to make something people won't actually hate. Although it is tempting to keep using Remix, you should move on once you get to the point where your decentralized applications compiles very properly. Next, you should use tools such as Truffle and TestRPC that help you simulate a real blockchain so you can test your dApps in a more realistic situation. So let's talk about Truffle first. Okay, so let's head over to Truffle's website once. So as you guys can see by their website, it claims that it is definitely your Swiss Army knife if you're developing on the blockchain. So until now, the only way we used to interact with our contracts was to deploy them manually through a node console into a test RPC node and then load them using Web3. Now let me introduce Truffle to you. Truffle is a development environment, testing framework, and asset pipeline for Ethereum, aiming to make life as an Ethereum developer easier. Truffle provides the building blocks to quickly create, compile, deploy, and test blockchain applications. There are many tools and applications that fall under the Truffle suite, which is there to make your life easier. Let me show you a few of them. So first of all, we have Ganache. So Ganache is the same thing as TestRPC. Actually, TestRPC was deprecated and renamed to Ganache. So Ganache is a local test node that is used by Ethereum developers to test the interactions of their applications that they have developed with the blockchain that they're going to deploy it on. It's a very nifty tool if you're actually going into all the things like gas price of each transaction and how your transactions pile up and how your things are getting mined and how your consensus protocol works. Next, we have Truffle boxes. Truffle boxes allow you to focus on what makes your dApp unique. In addition to Truffle, Truffle boxes can contain other helpful modules like Solidity contracts and libraries, front-end views and more, all the way up to complete example of decentralized applications. Pretty interesting, right? Alright, it seems like I haven't talked about the networks yet, so let's get on to them. Ethereum has three types of networks. The mainnet, which lets you connect to the main blockchain. Then there are test networks. To test your decentralized application, Ethereum gives you the option of three types of test networks. So we have the Ropsten network, the Coven, and Rinkme. So apart from using test networks, you can create a custom network as well for local development. For local testing, we can use TestRPC or Ganache CLI that were discussed earlier. Now let's see how all these pieces fit together. So far, we've seen the various tools required to build an Ethereum dApp using Solidity. Now let's see how these tools actually interact with the blockchain when you try to create and deploy your dApp on the Ethereum network. So basically, a decentralized application front end can be made using any web application. The front interacts with the Web3.js, and this Web3.js library connects with the Ethereum node using JSON RPC. Apart from using Truffle for deploying and creating decentralized applications, you can also use get command prompt. Alright, so after a dApp is created, it is deployed onto the network. Here's how it is done. So the smart contract is compiled into a bytecode and is deployed to any of the peers. The static files are downloaded into the browser, and it is then connected using Web3.js via JSON RPC. And this is how a user can interact with the deployed app. Okay guys, so it's finally time that we commit to the demonstration that I had promised you guys at the beginning of the class. So before I actually start with the coding, let me just prep you up with the scenario that we are going to implement on blockchain. It's quite simple. Suppose you wish to transfer a property to your close one. Now if you would do that with our existing system, then you would find that there are certain problems or limitations that exist there. What happens is that since we use a central authority to transfer ownership of our property, this can cause delay, attract a lot of extra expenses, and also there's a chance of fraud. So how does blockchain be helpful here? So by using hashes to identify every real estate, it makes everything publicly available and searchable. Also, proponents argue issues such as who is the legal owner of a property can be remedied. Basically, blockchain is not going to replace government. Concerning how land is registered and monitored, it will make governance of land registration the simplest and most corruption-resistant possible. Most importantly, this will reduce frauds and ensure that properties cannot be sold more than once over the same entity. There is good reason to think that the blockchain technology could serve as the basis for a more reliable, cheaper, and more efficient land registry. In my opinion, one popular blockchain use case that has remained generally outside scrutiny has been land title projects. It's going to flourish in the coming years when industrialists seem to realize the true potential of blockchain technology. I hope you'll agree with me out here. Okay, so without further delay, let me show you guys how a property transfer can be used in a decentralized way. Basically, we are going to code a smart contract which is capable of handling the logic for property transfer. There are a few actions that we're going to perform. So firstly, we're going to insert some dummy properties to replicate the real world. These properties shall have basic characteristics, for example, address, location, flooring, etc. Make sure you create the demo entries from a single owner. This single owner shall assign the properties to you. If you try to replicate it in the real world, generally the government shall be signing the documents which say that now you're the owner of this property. So here in this case that you are building the solution for a government. Government shall be assigning the properties after verifying your original documents. Hence make sure that you generate the dummy properties by a single owner, and this shall be distributing it to multiple people. Next, any address can send the property from his account to other owners and check the ownership of the property before transferring it to other owner. Try to include as many general parameters as possible to keep the smart contract almost replicating the real-world transaction. After the successful transfer of the property, we need to be sure that the old owner is not able to send the property again. And finally, the new owner must be able to send the freshly received property to any owner that he wishes to. Now, like I told you, we're going to develop a smart contract. So basically, we're going to use Ethereum's platform for development. We'll code in Solidity language. And after that, we're going to code in Solidity language on the Remix IDE. And we're going to use Ganache CLI as our test network. So let's get started. So like I told you, we're going to develop a smart contract. So basically, we are going to use the Ethereum platform for development. We'll be writing our code in Solidity and using the Remix IDE for compilation and deploying. And we're also going to use Ganache for our test network, and to actually see our blocks have been transferred, we're going to use this thing called Block Explorer. So let's get started. So I'm going to write my code bit by bit and explain once I'm done writing a bit, and that's how we're going to go about it. Okay, so let's get started. So first of all, we'll have to open Remix on Chrome, and that's where we're going to write our code. So let's set that up. Yeah. So I'm going to write my code a little bit by little bit, and then once I'm done with a good chunk of it, I'm going to explain what I've done. So let's get going. So, okay, so let me just explain what I've done till now. We've created an address of the DA, which stands for Development Authority. So he'll be in charge of allotting everything and all the transferred properties. So this is going to take the first address of our test code when we run it. So next we have the total number of properties, which is a uint. Next, we've just made a function to start the property transfer, and it'll be the DA as the message.sender, which is basically the first address. Then we've created a modifier which will check if the sender is the DA in fact. And then we've created a simple structure for our property. And our property will have two members, and that is a name and whether it is sold or not. Next, we've created a mapping, and this mapping actually points to another mapping of an address. And this is for the property's owner. Next, we have the individual count of property per owner, and that is also denoted by a mapping, which is from address to UN 256. We've also created two events, and these events will be triggered as the name suggests. When a property is allotted, this event will be triggered, and when the property is transferred, these events will be triggered. Now let's go ahead and write the logic for our property transfer. So let's go to the functions that we just created. So the first function that we created is get property count of any address. This shall give us the exact property count which any address owns at any point of time. So this is basically done by passing it the address of the owner that we want to check, and it returns the number of properties that is owned by him. So we just run a for loop on the properties that is owned by him, and we increase the count and we return the count once we've done that. Next function is for allotting properties. So this function shall be only called by the DA, and this is only after the verification of the owner's address. So obviously we have the whole modifier only owner that we had created before to check if it is actually the owner or not. And if it passes everything, the property shall be allotted according to the logic that we give. So the property's owner will get mapped with the name, and it'll be mapped to the property name. And then we'll also fire the event that we had created, that is property allotted, and it'll fire with the message that property has been successfully allotted. Next, we check for the function isOwner. So this is to check whether the owner has the said property or not. If yes, it returns the index of the owner. So basically we have set up a flag, and if that flag is anytime set to false because the property is not owned by him, we'll actually come to know. So first we go through the individual count of the property per owner and check the owner's address. And if the property owner says that it is sold, so we break out of the loop and we set the flag as true. Next, it's important to note here that if the property is owned, we are returning I, which is the index of the owner, and else we're returning a very large number, which is basically something that cannot be owned. So next, we also have a function called string equals, and this is to basically check if two strings that are being compared for the property name are equal or not. And this is a really neat way to do it, and we're using one of the inbuilt solidity functions called SHA-3, which basically runs a hash function on both the string indexes, and both the hashes will be the same if both the parameters are the same, even if one change in the message and the hash will completely differ. So basically we get a true or false depending on that. Next, we have the function to transfer our property, and this takes in the to address and the property name. So basically the address we're transferring it to and the property name that we want to transfer. And it also returns a boolean which will say if it was actually successful, and a uint saying which owner it has been gone to and the index of the owner. So first we put a check owner variable and we actually check if it is the owner or not. Next, as we had said, if it's not 999 basically and it's still not sold, we are going to transfer the property. So basically we just have two steps. We have to declare that it is now sold and we set the flag as true. Next, after the loop, the flag is checked, and if the flag is still false, we are firing the event that owner does not own the property. And if the ownership actually gets changed, we actually fire the event property transferred and the owner will be changed. So instead of explaining me all this, let's go and run this thing. So before we run this, we actually have to set up our test network. So open up command prompt and just type in ganache CLI, and that should just get us going. So we have our 10 accounts that we're going to fiddle with. So the first account out here at index 0 is going to be set as the DA. And we also have to set up Block Explorer. So just start Block Explorer 1 second. Next, we go to the Run tab and we change the provider to the Web3 provider. Click OK, and yes, indeed, our provider is running at 8545. So as you can see out here, the first address has been loaded up and we have 10 accounts to fiddle with. So we are going to deploy our contract out here now. So first we have to allot a property to an address. So let's take the first address and allot it some property. So we'll give our property the name property1 and click on allot property. Okay, so once we've set up our environment, it's time to deploy it. So click on deploy and we get all the functions that we created. So first we need to allot some property. So we're going to use the first address that we get with the ganache CLI thing. Copy the address for you paste it, and give our property some name. So we're just going to call it property 1. Okay, so once we've done setting up our network and our block explorer, we go into the environments and change it to the Web3 provider, and we'll see that all the accounts that are running on Ganache are available here for us to play around with. So now it's time we deploy our contract. So click on deploy, and we see that we get all the functions. So the two state changing functions are shown in red, that is allot property and transfer property. So first we have to allot the property to some address. So we take the first address, we copy it down here, and we get the property name, property 1, and we commit the function. Now, as you can see here, that we have allotted the property, and you'll get the message property allotted successfully. We can even see the same in Block Explorer, and I'll show it to you in a short while. So now the main thing is we have to transfer the property. So we choose some other account, copy the address, come back to the same account for execution, and paste the address out here, and we're going to give it the same property that we just allotted it to the different address. So as you can see here, our transaction should be successful, and as you can see in our logs, we see that the owner has been changed for property 1. So now if this guy were trying to allot the same property again and again, that means there would be a double spending problem which is there in the central system. So on a decentralized network, this should be solved very easily. So let me just show you that double spending is indeed actually figured out. So if the guy tries to transfer the property again, so it should say that the property is not owned by him. So let's commit another transaction. And as you can see, we can't transfer the same property twice to say that the owner doesn't own the property. So let me just show you this on Block Explorer. So we visit localhost 8000. And as you can see, these are all the blocks that we've committed. So this must be the block. And as you can see, we can check all the gas that have been used, and we can see the transfer address to and the address from, and we can see everything, like it has 2 confirmation blocks above it. And also, yeah, this is a very neat part about blockchain. If you go to the 8th block, you'll see that it's an unconfirmed transaction. So that means it's still there to be mined. So if we go ahead and commit another transaction, suppose I want to do another double spending check and transfer this property again, you'll see out here that we've changed the state, and this thing will now get confirmed. As you can see, it has 1 confirmation above it, and that is this block, the 9th block that we've just created. So as you guys can see, if we use the property transfer use case on blockchain, we can actually solve the double spending problem in a very transparent and seamless manner. So this was just a very raw application with just a smart contract with no UI. If you guys want a UI, you can go to the Web3.js documentation and build a UI for yourself that can actually simulate this whole thing very intuitively. So that was all about today's video. I hope you all learned something today. That's it from me. Goodbye. Hi guys, my name is Arya and I'm from Edureka. Today I'm going to be talking to you all about Hyperledger. We're going to see what all the jazz behind Hyperledger is about. Why exactly does it hold a certain amount of significance in today's IT industry? Then I'm going to briefly demonstrate through a simplistic example as to how Hyperledger works. And then to conclude the video, we're going to go through some of the few Hyperledger projects that have gone really famous over time. So without wasting much time, let's jump into today's video. Now, before I tell you what Hyperledger is, let me tell you what Hyperledger isn't, because it's really easy to get confused in today's world with so many blockchain platforms around. So firstly, Hyperledger is not a cryptocurrency that so many people seem to be interested in today's world. Above that, Hyperledger is not a blockchain, and neither is it a company. So what exactly is Hyperledger? Well, to begin with, Hyperledger is a project under the Linux Foundation. So like other projects under the Linux Foundation, for example, Node.js, Aljoin, DroneCode, and many more, Hyperledger is also an open source development project where people from all over the planet can come and help Hyperledger get developed as a software and as a platform. Now, according to the executive director of Hyperledger, Brian Behlendorf, Hyperledger is an open source community of communities to benefit an ecosystem of Hyperledger-based solution providers and users focused on blockchain-related use cases that will work across a variety of industrial sectors. So what exactly does that mean? Well, in simpler terms and analogies, Hyperledger can be thought of as a software that enables developers all across the globe to develop blockchain-based solutions for their particular businesses. At this point, some of you who are slightly versed with the blockchain technology might be thinking that, hey, we have platforms like Ethereum. Why can't they do what Hyperledger does? Well, the ethos of Hyperledger is that it believes every business or industry is unique in its own ways, and applications tending to that service must be personalized, unlike the Ethereum blockchain, which runs on a very generalized protocol for everything that runs on its network. You will see what I mean in a short while. Now, let me give you a brief history about Hyperledger before delving deeper into its mechanics. So first of all, Hyperledger began as a small project by a limited number of developers who came from various sectors like finance, supply, and data management. All these people had one common goal in mind, and that is to make the blockchain as a technology more accessible to the world. So with these things in mind, developers started testing the interactions between applications and secure blockchain networks. While rigorous testing between the two, developers involved realized that public blockchains that require each peer to execute each and every transaction and run consensus at the same time too takes a huge blow when it comes to scalability, as the network takes a really exhaustive measure to ensure security. Above that, any transaction that has a measure of confidentiality and privacy attached to it cannot be executed on the blockchain due to its public nature, as every ledger on the network will get updated and confidentiality is lost. To understand the concept of a private and confidential contract, let's look at a simplistic example. Let's say Bob in India wants to buy chocolates from his friend Alice, who lives in Switzerland. As they were old friends, Alice decides to sell Bob her chocolates at a pretty generous discount. But the catch here is that Alice also supplies to a number of different markets, which still need to buy chocolates from her at the standard rate. Above that, to actually get her chocolates from Switzerland to India, there are a number of procedures to fulfill. For example, firstly, she sends her chocolates to the mailing service, which in turn validates the supply. After a product is packed and sealed, logistic verification takes place. After that, during shipping, distribution logic is verified and validated, and in the end, payment verification is done before the package finally reaches Bob. But the point here is that even though there are so many third parties involved in the transaction, they do not need to know about Alice's and Bob's special deal. Now, when this whole transaction is run on a public blockchain network, where every peer has to go through every transaction, confidentiality of the deal becomes void, and every single ledger on the network gets updated about Alice's and Bob's special deal. This is where Hyperledger comes and wins the game. On a Hyperledger-based network, the parties who are directly affiliated with the deal are connected. The ledgers that get updated about the special deal are only Alice and Bob, thus maintaining the private and confidential aspect of the contract. Let's see how Hyperledger actually pulls this off. It all starts with Alice looking up Bob through an app, which in return sends the query to a membership service, and sends the transaction only to the peers directly affiliated. Both the parties now will generate a result. In this two-party agreement, both results generated need to be the same for it to get validated. But in other transactions, where there are multiple different parties, other rules can also be applied as needed. The validated transactions are then sent to a consensus cloud for ordering. These ordered transactions are sent back to the affiliated peers and then committed to their ledgers. This same pattern of a transaction is needed by multiple industries, where private and confidential obligations are need to be met by multiple parties without processing everything through a single centralized authority. Now that I've told you what Hyperledger is, how it pulls off a permissioned blockchain network, let's go through the architectural changes that make this all possible. The most notable changes can be seen in the peers, which make up the whole network. The peers are separated into two different runtimes and three distinct roles, namely endorsers, committers, and consenters. While endorsers and committer peers are executed on the same runtime, the consenter peers are run on a completely separate runtime. This allows Hyperledger's modular architecture to allow properties like consensus to be a plug-and-play feature, which in return allows a high degree of personalization to the network according to the needs of the business. Now, let us go over the peer roles. Firstly, the peer role we are going to discuss is that of a committer. The most simplistic role is that of a committer node. Their only role is to append validated and ordered transactions to the specific ledger once returned by the consenters. Normally, a committer can work as an endorser on the same network, but as more and more restrictions are imposed on the network, the merging of endorsers and committers are completely avoided. The second role is that of an endorser. These nodes simulate the transactions pertaining to the network and also prevent the occurrences of non-deterministic and unstable transactions. It is important to note that while committers may or may not be endorsers depending on the network restrictions, All endorsers act as committers on a Hyperledger network. Lastly, we have the consenters, which work on a different runtime. These nodes are responsible for running the consensus algorithm on a network and can be very well thought of as the bodyguard of the network who validates every transaction, deciding whether or not it should be added to a ledger. Now that we know what Hyperledger is, where it's necessary, and how it works, let's compare Hyperledger to the two most renowned blockchain networks, and that is Bitcoin and Ethereum. Starting with cryptocurrencies, while Bitcoin and Ethereum both have their respective currencies, Hyperledger has no official coin. But if a business deems necessary that they need a coin for themselves, they can always implement one. Moving on to networks, Bitcoin and Ethereum are both highly public blockchain networks. Hyperledger, on the other hand, is a consortium blockchain, which is also known as a permission network. Talking about consensus algorithms, Bitcoin uses SHA-256, which stands for Secure Hashing Algorithm 256, and Ethereum uses another hashing algorithm called Ethash. Erstwhile, Hyperledger uses a completely new concept called practical fault Byzantine tolerance, which basically checks how much time a transaction has resided on a machine. Bitcoin has no support for smart contracts or any sort of business logic for that matter. On the other hand, Ethereum and Hyperledger both support smart contracts. Ethereum smart contracts are mostly written in Solidity, while Hyperledger smart contracts are written in chain code. On the topic of the language each network is written in, Bitcoin is written in C++, while Ethereum and Hyperledger use a mix of Golang along with Python or Java respectively. Talking about projects under Hyperledger, there are a few noteworthy ones, like Hyperledger Fabric and Sawtooth. Hyperledger Fabric is being extensively used in the supply chains and market networks, and Sawtooth has seen success in the fishing industry. There's also Hyperledger Iroha, which is used for developing blockchain-based mobile applications. Another project, Hyperledger Indy, is used for decentralized identification databases for business networks. Now let's summarize the topics we've covered in today's video. We started off by seeing what Hyperledger is. Then we saw the need of Hyperledger in today's IT industry. Thirdly, we saw how Hyperledger pulls off a permission blockchain network and the architectural changes that make them all possible. Lastly, we compared Hyperledger to the two most famous blockchain networks, that is Bitcoin and Ethereum. I hope you enjoyed today's video. If you have any doubts, you can always post them down in the comment section below. That's it for me today. Have a nice day. Goodbye.
Hi guys, my name is Arya and welcome to this video from Edureka, which will explain hash graphs to you. So without wasting much time, let's jump into the video. Okay, so this figure that you see on the left hand side of your screen is a hash graph. So a hash graph is basically a distributed ledger technology that was developed by Lehman Baird, the co-founder and CTO of the Swirl's technology group in 2016. So in short, it's basically a closed source patented software that has been marketed by the Swirl's people as a near replacement for blockchain. Whether it is a true replacement or not, that we'll see over time. But for this video, let's see how hashgraph actually works. So first of all, a hashgraph has members. So our members here are Alice, Bob, Carol, and Dave, and they're represented by the 4 lines that are going upwards on the left-hand side. So in this example, these guys are actually represented by A, B, C, D that are below each line, and each member starts by creating an event, which is a small data structure in memory, and it is represented on the diagram by a white circle. Now, each event is a container for 0 or more transactions. The community runs a gossip protocol, which means that each member repeatedly calls the other at random to sync with them. Now, the goal of the hashgraph's consensus algorithm is for members of the community to come to a consensus or agreement on the order of the events, and thus the order of the transactions inside the events, and to agree on a timestamp for each event too. So it should be hard for an attacker to prevent consensus or to force different members to come to a different consensus or to unfairly influence the order of the timestamps that are agreed upon. Now let's take a moment to understand the gossip protocol visually. Now in this case, Bob randomly chose to call Dave, and when they connected over the internet, Bob sent all the events he knew that Dave did not yet know. In this case, it was just one event, the one that Bob had created at the start. Now Dave records the fact that this sync happened by creating a new event, and this is the new circle which has lines going straight down to his last own event and diagonally down to Bob's last event. Thus, the graph of events form a record of how the members have actually communicated. Now Dave's new event is illustrated here. Firstly, it contains a timestamp and digital signature. Secondly, it has the transaction itself. Now an event is a data structure containing the two hashes of the events below itself. In this case, it contains the self-parent's hash, that is Dave's first event, and the other parent, that is Bob's first event. Now the events can optionally contain 0 or more transactions that Dave wants to send to the network. So an event is a container for transaction. Dave puts all the timestamps of when he created the event and when he digitally signs it too. Now when this event is gossiped, the signature is sent along with it. Dave then sends Bob all his events, including the new one that he just created. So that looks something like this. Now Bob then creates a new event recording the fact that they synced and including the hashes of the most recent event by himself and the most recent event by Dave. So basically, Bob's new event will have the hash of this event down here and this event that Dave had created right now. Now Bob randomly chooses Alice and sends her all the 4 events that he knows about. Now she creates a new one, as this continues forever. And the graph grows like a directed acyclic graph that only grows upwards. So this is a graph connected by cryptographic hashes, and therefore it is called a hash graph. Each event contains the hashes of the event below it, and it is digitally signed by its creator. So the entire graph of hashes is cryptographically secure. It can always grow, but the older parents are immutable and as strong as the cryptographic hash and the signature system used. It is useful to now define a round created for each event. A child never has a round created before one of its parents, so as time flows upwards in the diagram, the round created can only stay the same or increase. I'll explain how rounds are created in just a moment. But the important point is that as soon as you receive an event in sync, you can immediately calculate its round created, and anyone else receiving it will also calculate it by the same number. So now let's understand witnesses. So the first event that a member creates in each round is called a witness. Let's color Alice's witnesses yellow. So all the yellow dots that you see on the left-hand side on the hash graph are Alice's witnesses. So A1 would be the witness in round 1, which is out here. Then A2 would be the witnesses in round 2, and A3 is the witness in round 3. Now, let's also create witnesses for the other members. Okay, it's also possible for a member to have no witnesses in a given round. And now let's see the other witnesses that we're going to have. So the red ones are Bob's witnesses, and they are also similarly B1 in round 1, B2 in round 2, B3 in round 3, and B4 in round 4. Similarly, Carol's witnesses are colored green, and they are C1, C2, and C3. And Dave's witnesses have been colored brown, which are D1, D2, D3, and D4. Now, every witness has a property by which it is known to the network. So a witness can either be famous or not famous. Now let's see how we can actually calculate fame for each and every witness. So for each witness, we need to determine whether it is a famous witness or not. Now, for example, we will be determining the witness B2 is famous or not. So it's this red dot right out here, the witness of B in the round 2. So this is done by considering the witness in the next round. So the fame of B2 will be determined by considering the witnesses A3, B3, C3, and D3. So the idea for B2 to count as famous is that it should be seen by many of the witnesses in the next round. So there is now an election, now in which most of these witnesses will vote on whether B2 is famous. Now there will be a separate election for every witness to determine its fame. The witness of A3 can be seen by B2, and that means that there's an entirely downwards path. So as you guys can see that A3 has a downwards path which is represented by green out here. So A3 will vote yes. Now next, B3 also has a direct downwards path to B2. So B3 will also vote yes. Next, C3 also has a direct downwards path to B2. So C3 will also vote yes. And similarly, D3 will also have a direct downwards path to B2. So D3 will also vote yes. Now all 4 witnesses have voted yes. So we would expect that B2 will be declared to be famous. But the election isn't over yet. An election isn't over until the votes are actually counted. So the votes will be counted by the witnesses in the following round. So that means the votes collected in round 3 will be counted by the guys in round 4. So the votes will be counted by the witnesses in the following round, as I just said. So B4 will be counting the votes and D4 will be also counting the votes. Now the hash graph doesn't yet have an A4 and a C4, but as time goes on and more gossiping occurs, there may eventually be an A4 and C4, and they will count the votes too. Now B4 will collect the votes from every round 3 witness that it strongly sees. Now, to strongly see a witness, it isn't enough for there to be only a single downward path to the person that he is collecting the votes from. So there must be enough different paths to it so that together the paths go through a supermajority of the population. Now, supermajority is any number that is more than 2/3 of the population. And in this example, there are 4 members in the population. So any 3 of them constitute a supermajority. Now, in this example, B4 is strongly seeing A3. The red path goes from B4 to A3 through Alice and Bob, and the other red path goes through Alice, Bob, and Dave, as you just see out here through the animation I have created. There are no paths from B4 that go through Carol to get to A3, but that's okay because Alice, Bob, and Dave make up a supermajority. So Carol isn't really needed. In fact, the second red path alone would have been enough. So therefore, B4 collects the vote from A3, which is a yes, and now B4 will also try and see the votes from B3. So let's see if now B4 can strongly see B3 or not. So first of all, B4 has his first red path completely down through B3, which goes from Alice and Bob, and it also has a second path which uses Dave. So B4 certainly strongly sees B3, and it will also collect the vote, which is yes. Now B4 will also try and collect the vote from C3. So first it will check if it strongly sees C3. Now it has a path which goes from Bob, Dave, and Carol. So basically B4 also strongly sees C3. Now let's try that same thing for the 4 members, that is Bob, Alice, Carol, and Dave, to go through actually D3. So B4 will definitely count the votes from D3, which is also a yes. At this point, B4 has received a yes vote from a supermajority. So B4 decides that the election result is a yes. So this means that the consensus has come to the decision that B2 is indeed a famous node. Now, if B4 had seen 3 yeses and 1 no, it would still decide yes because that's a supermajority. If B4 had seen 3 yeses and no other votes because it couldn't strongly see one of the other witnesses, it would still decide yes because that's also the supermajority. Now, it's important to understand that for B4 to actually have a chance at deciding whether B2 was or A3 was famous or not, or B2 was famous or not, it would have to strongly see a supermajority of the witnesses. Now, if an event X has a parent with a maximum round created of R, then that event will usually belong to that round too. But if that event can strongly see a supermajority of round R witnesses, that event is defined to be round R plus 1, and so on. So in other words, an event is promoted to the next round when it can strongly see a supermajority of the witnesses in the current round. Now, let's run an election for whether C2 is famous or not. So I've colored C2 actually gray out here, and let's see whether it is actually famous. Now the red line shows that C3 can actually see C2, so C3 will vote yes for C2's fame. But there are actually no downward paths from A3, B3, or D3 to C2, so they all vote no. Now the votes are actually calculated by B4 again, and since it can see A3, B3, C3, and D3 strongly, it will therefore collect the votes from all of them. And the votes are no, no, yes, and no, so the supermajority says it's a no, and the consensus decision is that C2 is not a famous node. Now there is a theorem that says that if any witness is able to decide yes or no, then that is the result of the election, and it is guaranteed that all other witnesses that decide are going to decide the same way. So in this example, B4 was able to decide the election. If it had collected the votes that were more evenly split between yes and no, then it would have failed to decide. In that case, we can consider D4. Now, if D4 also fails to decide, then perhaps A4 or C4 might decide it. And if none of the 4 witnesses can decide, then each of them will simply vote in accordance with the majority of the votes that they collect, and voting yes in case of a tie. Now, in that case, it will be up to the round 5 witnesses to collect the votes from the round 4 witnesses, and perhaps the round 5 witnesses will be able to decide. The voting continues until it eventually reaches a round where some witnesses can decide the election. Now I've done the calculations for 6 more elections on a hashgraph simulator, and the famous nodes are as follows. They are A2, B2, D2, A1, B1, C1, and D1. Now in normal operations, most events are not witnesses, so there is no election for most events. And most witnesses are declared famous with an almost unanimous vote in the first round of voting. So most elections do not actually last very long. Now we have to decide the fame of every witness in round 2. Now once a round has the fame decided for all of its witnesses, it is possible to find the round received and find the consensus timestamp for a new set of events. So let's start by considering the black event just below A2. Now this event can be seen by every famous witness in round 2 that I've colored green. So these are the paths that they can see them by, as I've just shown, and this merely requires seeing and not strongly seeing. Now since the black event is seen by all of the famous witnesses in round 2, it is said to have received a round 2, or basically the round received is number 2. Now let's come to the consensus timestamps. Now the consensus timestamp for the black event can be found as follows. So firstly, we find the earliest event X by Alice, that is an ancestor of A2 and a descendant of the black event. So basically this yellow event out here that we see is the node that we are talking about. Now we have to similarly do the same thing for B, C, and D. So similarly, we find the earliest event Y by Bob, that is the ancestor of B2 and a descendant of the black event. And similarly, we find an event Z by Dave and then take the timestamps of the event XYZ that were put in those events by their creators, sort all the timestamps in order, take the middle one from the list or the second of the middle two if they were an even number. And this median timestamp is actually the consensus timestamp for the black event, which will then stand as a timestamp for all the transactions contained in that event. Now consider the gray event below B2. It is seen by B2, but not seen by A2 or D2. So it was not seen by all the famous witnesses in round 2. So it's received a round that is later than 2. Let it stay colored gray to indicate that it still hasn't received a round. We find the consensus for the 6 black events and the 4 dark green events. Now, these are the 10 events that have received the round of 2. And we need to sort these 10 events into an order that all the members will agree upon. Now, this agreed order is the consensus order, and this is done by sorting them in the order that they receive their rounds. So this process of voting, sorting transactions in order of timestamps, and their round receives keeps continuing, and the system serves as a list of all the ordered transactions that have been served on the network. Okay guys, so that was about hash graphs. I hope you understood this new and upcoming technology. That's it from me. Goodbye.
Hello everyone, this is Arya from Edureka. Today's video is all about blockchain interview questions. So first of all, we're going to discuss the blockchains in the market. Next, we're going to discuss the general blockchain questions that are asked in the interviews. And we're also going to go through the advanced blockchain questions. So let's begin. Now, if you see this graph, you'll see that since 2013 and 14, the job positions on LinkedIn have increased with an upward curve. All these job postings have been across multiple job segments. So if you observe the graph, the most number of job opportunities are coming up in the technology, that is the software field, and the financial services and insurance services. Then there are opportunities in non-technical domains as well, like media industries, telecommunication, professional services, and many more. So on an average, post 2015, you'll find blockchain has been quite a happening place to be in because everyone is exploring proof of concepts, trying to build solutions around blockchain, and that is what is driving the entire job postings in the market. Now, just to look at the forecast, going by the past trends, you see that what you see today is nothing compared to what we're going to see in the next 7 years. So in the next 7 years, the number of jobs in blockchain are going to grow by 16 times, which is quite a big number. So this is an opportunity. I personally feel that this is the right time to be in this field. And if you see on the right side of the slide, you'll find that if you know blockchain, there are 14 jobs for you. So that is quite a mismatch in the demand and supply. Alright, so let's come to the next part. I have divided the interview questions into 2 parts, namely advanced and general. We'll start with some of the basics but important questions asked in blockchain interviews. Then we'll move on to the more advanced interview questions. So let's get started with the general interview questions. So the most basic question is, what do you know about blockchain? And the answer to that is, blockchain is a decentralized distributed database of immutable records, where transactions are protected by strong cryptographic algorithms and the network status is maintained by a consensus algorithm. Now the blockchain is devised in such a way that to access any previous transaction, you have to traverse from the last created block to the block whose data you want to access. Now the second question is, what is the principle on which blockchain technology is based on? The answer to that is, basically, we can say that blockchain is a subset of distributed ledger technology. So we can say that all blockchains are DLTs, but all DLTs are not exactly blockchains. Moving on to the next question, what are the different types of blockchains that are available? So basically, at a high level, there are 3 different types of blockchains. One is public blockchain, which is open blockchains. So blockchain platforms like Bitcoin, Ethereum, Monero all come under public blockchains, which anyone can join. So if you want to become a part of any public network, You just have to download the software and you can start running the node on your own. You don't need to take anyone's permission, which basically makes these networks permissionless. Then the next type of blockchain is private blockchain. All permissions are kept centralized to an organization. Private blockchains allow only specific people in the organization to verify and add transactions to blocks, but everyone on the internet is generally allowed to view them. Some of the examples are multi-chain, block stacks, and so on. Now the third type of blockchain is called consortium. This is also a type of private blockchain, but this is managed by a group of individuals or by a consortium of members. Only predefined set of nodes have access to write the data or a block. Hyperledger is the most popular example of a consortium blockchain. Moving on to the next question, which is, why is blockchain called a trusted approach? Now the reason why blockchain is trusted is because of its immutability, which means that once a transaction is being written onto the ledger, you cannot modify it. Also, every participant has a shared source of truth. Basically, it distributes trust among different individuals of the network via an economic game wherein the individuals are incentivized to maintain the state and validate the transactions. Now the next question is, what type of records can be kept on the blockchain? Is there any restrictions on the same? So the answer to that is, there are no restrictions as such on any kind of data that you can actually store on the blockchain. There are different companies using different types of blockchains for holding all sorts of records. Some of common types that you see here are records of medical transactions, identity management, transaction processing, business transactions, managed activities, documentations, and so on. So there is practically no limit on the kind of data that you're pushing onto the blockchain. Alright, the next question is, blockchain is a decentralized database. How does it differ from traditional databases? So if you look at the table, it says that the record in blockchains are stored in a decentralized database. Whereas in traditional databases, the records are centralized. Talking about the operations, blockchain only has insert-only operations, while in databases, you can perform CRUD operations, which stands for create, read, update, and delete. Since the ledger in blockchain is distributed to the entire nodes of network, the traditional databases have more of a multi-master and master-slave architecture. Then there is consensus amongst the peers for coming to an agreement on the outcome of transactions, whereas in traditional databases, there is two-phase commit. Also, since blockchain is an open network, anybody can validate the transaction across the network. Whereas in traditional databases, there are integrity constraints, and not everybody is allowed to validate the transactions. Okay, the next question is, what are the key features of blockchain? So the most important feature of blockchain, you can say that it is a decentralized network also, and it runs by using a distributed ledger, where immutability is a very important feature, wherein data cannot be modified or deleted, which is why we can say that it is a safe and secure ecosystem. And the last feature is that it has the concept of mining, which is very specific to a blockchain. Okay, so the next question that we have is, what is encryption and what is its role in blockchain? So encryption is basically a way to secure the data. Encryption is used when you don't want someone else to be exposed to your data. The data is passed through some sort of cryptographic algorithm to scramble the data in such a form that it is not readable to human beings. So that data is basically protected by the keys, and only the person with the cryptographic keys can decrypt or decode the encrypted data. Now this approach is really useful in blockchain because it makes the system secure and adds to the overall authenticity of the blocks and the blockchain. Any data in blockchain is encrypted using state-of-the-art cryptographic algorithms, and the blocks are linked together using the encryption techniques. That is what makes it so useful and secure. Okay, let's move on to the next question. So the next question says, what do you mean by blocks in a blockchain technology? Well, we said that blockchain is a distributed ledger that contains a list of transactions. Now these transactions or records are stored in the form of blocks. The blocks are necessary to maintain the order of transactions in blockchain, and each of this block is linked to each other in a sequential form. So whenever a new transaction comes in, it is added to the block. This block is linked to the latest previous block, and so on and so forth. Now the next question is, how is a block recognized in the blockchain approach? So every block in the blockchain consists of a pointer which acts as a link to the block prior to it. So every blockchain has a header which has the transaction data, timestamp, and also the hash of the previous block. So every block is linked to the previous block using the hash pointer. Okay, so moving on to the next question. This should be very basic. Is it possible to modify the data once it is written in a block? So as we all know, blockchain is immutable, so the answer is obviously no. We saw earlier that transactions or records in a blockchain can only be written in once, and it cannot be changed. Since all the records are secured by cryptographic algorithms, any changes in any of these records will result in the change in the hash of all the blocks prior to it, so the chain breaks. So because of this, it cannot be modified because it will change the hash of the entire directory. Now the next question is, what are block identifiers? In a blockchain, there are ways to identify blocks, and these are called block identifiers. Basically, there are two ways to do that. Every block has a block header which points to the previous block, and then we have a block height. The block height is nothing but the number of blocks in the blockchain. So basically, you can identify the block with the block header hash or the block height. Moving on to the next question. Is it possible in blockchain to remove one or more blocks? Well, this is a very easy question, and the answer is no. This is not possible, as removing or detaching any block will disrupt the hash header of all the previous blocks, so you just cannot do this. Moving on, what exactly do you know about the security of a block? So the primary method of protecting a blockchain is by using cryptographic hash algorithms, and each block is linked to another using a hash pointer. So any modification in any records will change the hash identifier of the whole block. Also, one more thing which makes the blockchain secure is the consensus algorithm. The consensus mechanism maintains the state of a blockchain and also acts as a network servicing protocol. Moving on to the next question. What are Merkle trees and how important are Merkle trees in blockchain? So Merkle tree is also known as the hash tree. It is the data structure in blockchain in which each leaf node is a hash of a block of data and each non-leaf node is a hash of its own child nodes. Merkle tree helps you identify a specific data very quickly. Let's say we have 1,000,000 blocks and we quickly want to identify a transaction or block. So the Merkle helps us do it without traversing the entire history of transaction. Alright, let's have a look at the diagram shown here. So if you see, the Merkle tree summarizes the transactions in a block by producing a digital fingerprint of the entire set of transactions. So what do we mean by this is that Merkle trees are created by repeatedly hashing the records together until there is only one hash left. In the diagram, you can see that there is a transaction root at every block, and this transaction root is derived from Merkle tree, and this Merkle tree actually derived from hashes of pair of transactions. Moving on to the next question, what is a ledger and is blockchain an incorruptible ledger? Let's have a look at the first part of the question. So the ledger is simply a record of transactions, and these transactions are nothing but transfer of value. Person A transfers some money to person B, and that becomes a transaction, and such type of transactions are recorded in a ledger. Now blockchain is considered incorruptible, and so what do we mean by this? What we mean is that you cannot hack or corrupt the ledger simply because it is distributed, and if you want to corrupt a ledger, you have to control more than half of the network's computational power or nodes. And doing this is not an easy job because if an attacker wants to control this and try to control the money for himself, he has to invest huge computational resources. So should it happen? Basically, if someone has control of more than 51% computing power in a network, that person would take every precaution to avoid being noticed. But the resources required to take control of such a system is huge. But it is near impossible for one person or community to have such huge computational power. Alright, so let's move ahead. So the next question is, name the common type of network systems that are extensively being used in various applications. So there are three types of network systems. One, you have a centralized network. Secondly, a decentralized, and third, a distributed type. So what happens in a centralized network is that every participant or node in the network can talk to each other only through a centralized node or server. You can see that from the leftmost diagram. If you look at the second one, it represents a decentralized network. So instead of nodes talking to one single server, you can actually group nodes such that few of them have single centralized server, and each of these centralized servers talk to each other. Now in a network like Bitcoin and Ethereum, where we say that it is a distributed network, what happens is that every node talks in a peer-to-peer manner. There is no centralized server of any kind in the system at all. Moving on to the next question, how is a blockchain ledger different from the ordinary one? So in a blockchain, same copy of ledgers exists in the entire network, while in the ordinary system, the ledger may or may not be the same. In blockchain, you only have options to create and read, whereas in ordinary ledgers, you can perform all CRUD options. Now, these are some of the basic differences between blockchain and ordinary ledgers. Moving on to the next question, and this is a very interesting one, which says, what do you mean by mining? So mining is the process of transaction verification and adding those transactions to the block. Now, how does this happen? So there are special nodes called miners which use state-of-the-art cryptographic algorithms to validate the transaction across the network and add these transactions to the block. Okay, so moving on to the next question again. A distributed digital ledger is used for recording transactions on a blockchain. What does the system rely on? So the answer to that is, when we say that what we are recording transactions in a distributed ledger, The underlying network is basically composed of different nodes. So the system relies on the nodes or the full nodes and the mining nodes, which are responsible for maintaining the security and smooth running of the system. Next question, can you explain the components of a blockchain system? Okay, so the answer is pretty simple. The basic components in a blockchain ecosystem are the shared ledger, which is the digital ledger distributed among the peers. And then there is a node application which you install and run on a computer to become a part of a particular blockchain network. Then there is a virtual machine where the instructions are implemented and every participant in the ecosystem runs that virtual machine. Lastly, of course, there is a consensus mechanism which is implemented as a part of the node application. It provides the rule for how the ecosystem will arrive at a single view of the ledger. Moving on to the next question, we have state the difference between how proof of work and proof of stake. So we have properties of proof of work and proof of stake. In proof of work, the probability of mining a block depends on the amount of work a miner does for validating the mining of a block, whereas proof of work has stakeholders and they validate new blocks by utilizing their share of coins on the network. Next point is that proof of work takes more energy than proof of stake, which is why Ethereum is gradually shifting to the proof of stake consensus mechanism. Proof of work takes up computer speed for mining blocks, while in proof of stake, user needs to own a majority of coins in order to attack the network. Moving on to the next question, name some of the popular platforms for developing blockchain applications. So people are experimenting a lot with blockchain technology, which is why there are so many platforms coming up for the building of blockchain applications. Some of the popular platforms are Ethereum, Hyperledger Fabric, Corda, Cardano, IOTA, and Quorum. So some of these networks are public networks that also work in a private setting, like Ethereum is a public network, but you can also deploy it in a local setting, whereas Hyperledger Fabric is completely private and permission network where it has no concept of a coin and it is purely used in a consortium and private manner. Now moving on to the next question is, what is double spending and is it possible to double spend in a blockchain system? So double spending is a condition where one digital token is spent multiple times because the token is a digital file which can be easily copied. Now what happens is a person named A try to send some coins to person B and person C at the same time. The blockchain prevents such a case, since the transactions are confirmed by multiple parties and it is not possible to double spend a crypto token in a blockchain. Moving on to the next question, what are the benefits of blockchain that you know of? So there are some major benefits of using blockchain, which is why blockchain has become popular in recent times. Transaction settlement in blockchain happens in real time, so any transaction is peer-to-peer and the network itself verifies the transaction, which makes the transaction much faster. And since there are non-third parties involved, the transaction cost is also minimal. Again, the transaction and the system is secured by strong cryptographic algorithms, which in turn accounts for the immutability. Then there is an important property called user pseudonymity, which means that flow of transactions are tracked by user addresses. Okay guys, that was the end of the general interview questions. Now we'll move on to the more advanced section, which you might be asked to you in your interviews regarding your blockchain career. So let's dive into them. So the first question is, can you tell me about some of the widely used cryptographic algorithms used in blockchain? So some of the widely used algorithms in blockchain include algorithms like DES, where DES stands for Digital Encryption System. Then we also have the RSA algorithm, which is used in numerous areas concerned with digital certificates. Other algorithms include Twofish, Blowfish, and AES. Out of all these algorithms, AES is the strongest encryption algorithm to break. Moving on to the next question, we have, what do you know about forking in blockchain, and name the types of forking? Okay, so at the most basic level, a fork is what happens when a blockchain diverges into two potential paths forwards, either with regards to a network transaction history or new rule in deciding what makes a transaction valid. But forks can also be willingly introduced into the network. This occurs when developers seek to change the rules the software uses to decide whether a transaction is valid or not. Forking in each and every blockchain is different and based on the design architecture and use case for which the chain is meant for. So essentially, there are two types of forking. The first kind is a soft fork, and this means that in any change is backwards compatible. Then we have a hard fork, and in this the software upgrade that introduces a new rule to the network is incompatible with the older software. Okay, so the next question is, explain the significance of blind signatures and how it is useful. So let's tackle the first part of the question first. So a blind signature in cryptography is when digital signature is generated for a certain content, with the content itself being disguised or blinded. This generated blind sign can be verified against the original unblinded messages using conventional decryption techniques. The message is blinded by the author and signed by a different party. This system is generally deployed in privacy-related protocols, for example, electoral processes, polling campaigns, digital caching systems, etc. So moving on to the next question, which is what is secret sharing and does it have any benefit in blockchain technology? So secret sharing, also called secret splitting, refers to methods for distributing a secret amongst a group of participants, each of whom is allocated a share of the secret. The secret can be reconstructed only when a sufficient number of possibly different types of shares are combined together. Individual shares are of no use on their own. Secret sharing essentially allows data to be stored in a decentralized way across n parties such that any k parties can work together to reconstruct the data. But k1 parties cannot recover any information at all. N and k can be set to any values desired. All it takes is a few simple parameters tweaks in the algorithm. Now, it has its benefits in blockchain technology as it allows private content to be divided into small parts and be sent to the destination on a decentralized network. So moving on to the next question, which is, can you explain what are off-chain transactions? So off-chain transactions refer to those transactions occurring on a cryptocurrency network which move the values outside the blockchain. Due to their zero or low cost, off-chain transactions are gaining a lot of popularity, especially among large participants. Off-chain transactions can be better understood when compared to on-chain transactions. An on-chain transaction, which is simply called a transaction, occurs and is considered valid when the blockchain is modified to reflect the transaction on the public ledger. It involves the transaction being validated and authenticated by a suitable number of participants, recording of the details of the transaction on the suitable block, and broadcasting the necessary information to the whole blockchain network, which makes it irreversible. This kind of transaction can be reversed only after a majority of the network's hashing power comes to an agreement. Essentially, every step linked to an on-chain transaction occurs on the blockchain, and the blockchain status is modified to reflect the occurrence and validity in the transaction. In contrast, an off-chain transaction takes the value outside the blockchain. It can be executed using multiple methods. Okay, so moving on to the next question, which states, what do you mean by anonymity and pseudonymity in cryptocurrencies? Well, an anonymity network enables users to access the network while blocking any tracking or tracing of their identity on the internet. This type of online anonymity moves internet traffic through a worldwide network of volunteer servers. Anonymity networks prevent traffic analysis and network surveillance, or at least make it very, very difficult. A good example of this is Zcash. Now, let's discuss pseudonymity. So sometimes it is desired that a person can establish a long-term relationship with some other entity without necessarily disclosing personal identifying information to that entity. In this case, it may be useful for the person to establish a unique identifier called a pseudonym with other entities. Examples of pseudonyms are pen names, nicknames, credit card numbers or student numbers, bank account numbers, etc. Well, for a blockchain, it is mostly the block address or the account address. A pseudonym enables the other entity to link different messages from the same person and thereby to establish a long-term relationship. Now let's move on to the next question, which says, how does peer discovery work in a P2p network? So the answer to that is, on a decentralized network, when a node boots up, it has no idea about the network. Since there is no centralized resource, the most practical way would be to connect to the first discoverable node. This has certain drawbacks though, as the trust and integrity of that node is completely unknown. To address this problem, developers have hard-coded a list of trusted node parties into the network. When a node boots up, it initially connects to these trusted nodes and then begin their node discovery process by just connecting to the other node connected to these trusted nodes. This trusted list is a very small fraction of the entire number of systems on the network and therefore do not hurt the decentralized aspect of the entire system. Moving on to the next question, which is, what is a 51% attack? In my opinion, this is one of the most important questions when looking at a blockchain interview. So let's see the answer. So as its name implies, a blockchain is a chain of blocks, bundles of data that record all completed transactions during a given period of time. Once a block is finalized, mined, in the jargon it cannot be altered since a fraudulent version of the public ledger would quickly be spotted, rejected by the network's users. However, by controlling a majority of the computing power of the network, which is basically 51%, an attacker or group of attackers can interfere with the process of recording new blocks. They can prevent other miners from completing blocks, theoretically allowing them to monopolize the mining of new blocks and earn all of the rewards. They can block other users' transactions also, They can send transactions, then reverse it, making it appear as though they still had the coin that they just spent. This vulnerability, known as double spending, is the digital equivalent of a perfect counterfeit and the basic cryptographic hurdle the blockchain was built to overcome. So a network that allowed for double spending would quickly suffer a loss of confidence. Now moving on to the next question, which says name organizations that can use blockchain technology. So any service that follows the current centralized architecture could implement blockchain in their business. Services that have any sort of online or financial transactions could make their process seamless with the help of blockchain. Nowadays, with private blockchain services like Hyperledger, even confidential processes regarding government and defense could be implemented through blockchain. The possibilities are really endless, and we are just on the road of discovery. Moving on to the next question, we have what are the core requirements for a business blockchain? So let's first look at what exactly is a business blockchain. So business blockchain, as the name suggests, is a blockchain service that can be implemented for businesses mostly private in nature. In these cases, mostly a private or consortium blockchain is used. The requirements of a business blockchain are as follows. Firstly, we need a shared ledger, which is a common aspect of every blockchain. Secondly, there needs to be privacy and permissions. Most businesses have certain rules regarding content sharing amongst this organization. In this case, a high amount of privacy and permissions at different levels of the network are required. This is essentially provided by a consortium blockchain. Thirdly, we need smart contracts. The business always needs to implement business logic on the blockchain, and the only way to do this currently is with the implementation of smart contracts on the system. Last but not the least, we need a consensus algorithm. Just like every blockchain, a consensus protocol is obviously required for the validation of blocks into the new chain. Now moving on to the next question. What are the key principles in blockchain that are helpful in eliminating the security threats that needs to be followed? Okay, so there are a few principles to be followed for eliminating proper security threats, but this is not specific to blockchain as they can be applied to any general network. So firstly, we need to have a proper auditing process. Secondly, applications must be secured with proper role-based access control system, and there should be proper testing of every unit and the integration also. Next, the database, that is distributed ledger in this case, must be secured and encrypted using up-to-date encryption functions. Also, there should be sufficient continuity planning, and there must be ample training of the workforce to follow these best practices. Okay, so moving on to the next question, which is the blockchain different from banking ledgers? Okay, so banking uses ledgers for timestamps and transaction records just like a blockchain, but the main difference lies is in the fact that bank ledgers are not public. They're controlled by centralized authorities, that is the bank, unlike a blockchain which is completely public and open source. Moving on to the next question, can you list some of the popular consensus algorithms and why do we need different consensus mechanisms? Okay, so some of the most popular consensus mechanisms are PBFT, which stands for Practical Byzantine Fault Tolerance, Proof of Work, Proof of Stake, then there's also Proof of Burn, Delegated Proof of Stake, and Proof of Elapsed Time. Now we need different consensus mechanisms, mostly to cater to different business models. Also new consensus mostly provide an optimization in terms of storage and performance. Other things can also be implemented like regularization requirements, implementation, performance, tokenization, security, privacy, etc. So moving on to the next question is there any network-specific conditions for using blockchain technology in an organization? So the only basic requirements for a network to implement blockchain is that it must be a P2p network. It helps validate the new blocks simply and helps organizations to keep up the pace in this matter without investing in third-party applications. Moving on to the next question, name the steps that are involved in the blockchain project implementations. Well, there are a total of 6 steps involved in this process. Firstly, we need to decide if we can use an existing blockchain for our purposes. For this, we need to do some requirement identification. After the requirement identification has been done, we need to screen all the ideas that have been come up while the brainstorming was being done. Next, we actually take the idea that has been chosen and implement it through some successful project development cycle. Next, we have to do some feasible study on the security and implementation. Last but not the least, we have to also take care of controlling and monitoring the project. So these are the 6 simple steps that you need to follow when deploying your blockchain project. Moving on, explain a real-life use case where blockchain is being used. So this is very easy. I have an example in front of you, which is Storj. So Storj is an open source decentralized file storage solution. It uses encryption, file sharding, and a blockchain-based hash table to store files on a peer-to-peer network. The goal is to make cloud file storage faster, cheaper, and private. Traditionally, cloud storage solutions like Dropbox or Google Drive have limitations. While files are backed up redundantly, bandwidth from a data center or unexpected outages can restrict access to your files. There are also issues of privacy, and these companies have complete control over your files, including the ability to access them. The StoreJet project uses blockchain and peer-to-peer network to solve these problems. It distributes the files so redundancy is well established. It also guarantees you're only one who can access your files. Now moving on to the next question, which is, what are sidechains? So a sidechain is a separate blockchain that is attached to its parent blockchain using a two-way peg. The two-way peg enables interchangeability of assets at a predetermined rate between the parent blockchain and the sidechain. The original blockchain is usually referred to as the main chain, and all additional blockchains are referred to the sidechain. The blockchain platform Auger refers to its sidechains as child chains. A user on the parent chain first has to send their coins to an output address, but the coins become locked so the user is unable to spend them elsewhere. Once a transaction has been completed, a confirmation is communicated across the chains, followed by a waiting period for extra security. After waiting the period, the equivalent number of coins is released on the sidechain, allowing the user to access and spend them there. The reverse happens when moving back from a sidechain to the main chain. Now moving on to the next question is, can you name one major limitation of blockchain? So as everyone knows, cryptocurrencies has had a fantastic year in 2017. But now with more tokens, users, investors, exchanges, and startups involved than ever, scalability is emerging as a serious issue. With transaction data piling up, the current system is beginning to strain under its own weight. With every purchase, the blockchain adds one more block to its ladder of transactions, and every block increases with data as it carries the history of the block before it. As more users join the network and transaction histories of individual coins grow, the current system is in danger of buckling. So, as we see, scalability is basically the major issue in blockchains today. Now moving on to the next questions, are there any alternatives to blockchain? So, yeah, there are actually alternatives to blockchain. Hashgraph is a new consensus alternative to blockchain. It uses a gossip protocol that works in the following manner. Every node in Hashgraph can spread signed information called events on newly created transactions and transactions received from others to its randomly chosen neighbors. These neighbors will aggregate received events with information received from other nodes into a new event and then send it on to another randomly chosen neighbor. This process continues until all the nodes are aware of information created or received at the beginning. Due to the rapid convergence property of gossip protocol, every piece of new information can reach each node in the network in a fast and very easy manner. Okay, now moving on to the next questions. Do you know the means to scale a blockchain technology? Well, the first method to actually scale a blockchain technology is a Lightning Network. Now this was proposed to a solution to Bitcoin scalability. So what it does is implement off-chain transactions, which means basically not the entire list of transactions happen on the main chain. Only the first transaction may happen on the chain, then all the following transactions happen on a side chain, which takes lesser work and lesser space. And then the final transaction is again updated on the main chain, maintaining the integrity of the network. While this is a skewed approach, it kind of works in today's world. Next, we have SegWit, which stands for Segregated Witness. So in SegWit, the signature data will move on from the main chain to the extended block in the parallel chain. What this will do is that it will free up a lot of space in the block itself for more transaction. It was envisioned that the signature data would be arranged in the form of a Merkle tree in the sidechain. The Merkle root of the transaction was placed in the block along with the Coinbase transactions. However, on doing this, developers stumbled upon something unexpected. They discovered that on putting the Merkle root in the particular place, they somehow increased the overall block size without actually increasing the block size limit. After that, we have another practical approach, which is increasing the block size. So with increasing transactions, the possible solution is to actually increase the block size to just accommodate more transactions. But in my opinion, that's just a lazy approach. Lastly, we have sharding. Now, sharding is a scaling technique that was inspired by a traditional concept of databases sharding, whereby a database is partitioned into several pieces and placed on different servers. In the context of a public blockchain, the transaction load on the network would be divided into different shards comprising different nodes on the network. As a consequence, each node would process only a fraction of incoming transactions, and it would do so in parallel with other nodes on the network. Breaking the network into shards would result in more transactions being processed and verified simultaneously. As a result, it becomes possible to process more and more transactions as the network grows. This property is also referred to as horizontal scaling. Now we could imagine that existing blockchain operates like a busy highway with one toll station operating only on one toll booth. The result would be a traffic jam as people wait in long lines to pass the toll station. Implementing a sharding-based blockchain is like adding 15 or 20 toll booths to the highway. It would dramatically improve the rate at which traffic can progress through the stations. Sharding would make a tremendous amount of difference and dramatically improve transaction speeds. So moving on to the last question of the session for today, we have, with blockchain came the Web 3.0. Can you name some of the decentralized blockchain-based applications that will bring about the next level of the internet? So the answer to that is, you could name some of the applications that have been actually implemented through blockchain. For example, browsers like Chrome have been implemented in a decentralized manner called a Brave browser. Then we have storage file systems like Storj and IPFS. We have operating systems like Essentia and EOS, and social networks like Steemit. So as you guys can see, there are a lot of blockchain-based applications that are actually replacing all the currently centralized services. So yes, indeed, we can actually call the internet run on blockchain the Web 3.0. So guys, that was the end of all the blockchain-based questions that you might face during your interviews. I wish you the best of luck for all the interviews that you might be appearing for. That's it from me. Goodbye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!